All right. Good evening, everyone. Welcome to today's session. We will cover mock in-term paper, and then we will discuss. We will see. What all topics are. Important. How you should prepare for in-term paper. Okay. Yeah. I'll share my screen. Yeah. I think here in-term mock paper. Right. It's better to see the answers also, so that we can directly compare. Okay. Yeah. So okay. I hope the screens are visible. My audio is clear, right? Yeah.
Yeah, yes, sir.
Yes.
Thank. Thank
Yes,
you.
sir.
Okay. Okay. Yeah. So in the first question, it asks about. Okay. In the first question, it asks about to do the max upscaler and using max upscaler, we have to give the minimum value. Okay. After using this input. Okay. So what after using this scaling transformation? Okay. So in max upscaler, what we do is that we take the maximum value and maximum absolute value, and we we divide all value from that. So it since it is asking about, so here the maximum value is -4. Okay, so we have to divide all values by 4 only. So okay, so it will be something like this. Okay, so out of this, it is asking us to give the minimum value. So minimum value here, this will be -3 by 4, 0, minus half, plus half, half, minus 0.5, okay, and -1. So this value will be the minimum value, right? So in this
Hmm.
case, this would be the answer. Okay. Yeah. So yeah, along with this, I think there are different things. Okay, in pre-processing you have max scalar, and there are other pre-processing steps also. Okay, just to practice those. Okay, just see how those function works. Okay. So yeah, yeah. Okay,
Sir,
yeah.
in this one, MaxF scalar directly takes the range, right? Means like the range is between -1 to 1. It is case that in that
Correct,
particular
correct,
range, right?
correct,
So
correct.
I use
So
that particular approach.
yeah. So see, -1 to 1 is there, right? So it is, so that is the maximum value. So it is not possible. No, every time you will get -1 only. Okay. For
Okay.
example, here, let's say if this would be the instead of this -4, if it would be +4, so you won't get to -1 as the minimum value,
Hmm.
right? So it will be somewhere, I think, minus zero point 0.5 or minus zero point 0.5. Yeah, minus zero point 0.5. Yeah,
Minus point
minus
five, sir.
two. Yeah. So that would be the minimum value. So that is there.
Hmm.
So yeah, that is there. Okay. So let's move to the next question. So question two says, okay, and yeah, regarding this, if you see, if you compare it with the standardization or min max scalar, so if you see, no, here we don't subtract it from the mean value. Okay. So the data always retains its original distribution in this case. Okay. So it just shifts them to the lower range. Okay. So that's why you do not handle outliers in this case. Okay. If some outliers are there, then that will be, here also, the same pattern we follow. Okay, we, since we do not shift the mean values and all, no, so that's why. Okay. And other than this, I think is yeah, stay in standard scale we shift the mean values also. Okay. uh, is there any question? Yeah, Sivan.
Uh, so there is any range for a standard scalar like max
uh
absolute scalar?
yeah, in standard scale, basically you shift mean to 0, and standard deviation you set standard deviation as 1. Okay. So
Okay.
that you do.
Thanks,
Okay.
sir.
Huh. So okay, let's move to the question number 2. In question number 2, given below a wide trend list which consists of a coffee orders preference by the customer in a cafe. Okay. So these are the samples. First one, large cold, small hot, large hot. Okay. We have to use multi-level manager from sklearn library. Okay. To convert wide trend into numbers. Okay. So which of the following option matches with the output of the following codes? So we have to check which one will match. Okay. Here, since we have already given that there will be 4 classes. Okay. We have defined classes as 4. So for each sample, no, there will be 4 type of output. Okay. There will be 4. 4 numbers. Okay. So here, so for option D and option B, directly we can ignore that. Even option C also. From this approach only, we were able to get that option A will be the correct answer. Okay. So
Sir,
yeah.
sir, how do we understand when class is equal to four classes, then the number of, it will
Yeah.
decide the
So
number
yeah.
of columns?
So here on, we have mentioned classes. I mean, four classes. So always the classes will be, I mean, the number of unique values. Okay, out of these things. Okay, so that many class you have to define. Okay, basically, I mean, multi-level binary helps you to convert. Okay, it simply helps you to convert multi-level data into a binary matrix representation. Okay, whenever you have multi-level data, no, okay, multi-level data is an output, no, so you simply convert it into some binary matrix representation. Okay, I mean, all the values will be 1 or 0. Okay, and for, I mean, for each instance, no, it will, I mean, for each instance it will give you multiple labels. Okay, I mean wherever it is one, no, wherever it is present, for that it will show it as a one. For example, this is a cold, hot, large, small. Okay, this, I mean, for each sample, no, you will get these four values. Okay, since it is large, no, so for cold it is 0. Okay, okay, yeah, okay, yeah, for cold it will be 0. Okay, and then, okay, for hot it should be, okay, hot is also not there. Okay, then you, okay, uh cold is not there. Okay, let me see again. Okay, yeah, so first of all, what
This
you
is
have to
fine,
do.
right?
Yeah,
One because large is cold, so it is one. Then second is hot. Sorry, second is cold, but the label is for hot, so it is not hot, so it is cold, so it is zero. Then if it is large, but it is actually hot, so it is not right. So
say again, I mean, I am not getting what you are saying.
the label for it.
Okay, so here, what you are saying is that, so, okay, maybe just say again. Okay, then I'll understand what you want to try, what you are trying to say.
So the first thing, like the labels are fine, right? 1010.
Uh-huh. Hmm.
So it is large. So sorry, it is cold, right? So it is one. Then in the second thing, it is saying hot, right? For the second column. So it is actually not hot. So it is zero. It is actually large, right? That data pair is large cold, right? So it is one. Then it is and the last one is small. It is not small, so it is zero. So this is fine, right?
Yeah. So this is what I'm also trying to say is that, so whenever you have the classes, no, I mean, for each classes there will be values. Okay, if that is present here, no, it will represent as one, and if it is not present, it will represent as 0. Okay. So here in this one, no, cold, hot, large, small is there. Okay. For cold, no, it is present in this for first temple. So that's why you have one. Then hot is not present. So that's why it is 0. Large, it is present. So that's why it is one. Small, it is not there in the first sample. So that's why it is 0. Right? I think you were also trying to say same thing, right?
Yes, sir. Exactly,
Or
sir.
something. Yeah. Yeah. So like this only, for first sample you got 1010. Let's talk about the second sample. In the second sample, what happens is that in this one, small and cold is there. Okay, so here again if we will see this one, cold, it is present, so that's why first is 1. Hot, it is not present, so that's why you are seeing 0. Hot, okay, I mean, large is not present, so that's why again 0. Okay, then small is present, so that's why 1. Okay, so that's how multi-level binary works. Okay, I hope it clears. Okay, then let's move to the next question. Next, or we
So
can.
one thing, it's always level always given according to the alphabetical order, sir.
Okay, by default it gives you the, by default, if you go, no, it will be level will be as per the alphabetical order. Okay, but if you want to put some other labels, that you can do. Okay, that you
Okay,
can
it's
mention
depend
here.
on the given order, sir.
So whatever order you is set here, no, so you will get the levels like that only. Okay.
Okay, okay.
Okay,
If
so
we if we if we give classes, then right. Otherwise,
right, yeah, otherwise by default it will be, will follow alphabetical order. Okay, for example, let's say, I mean, there is some, okay, I mean, yeah, you understand. If the you mention classes, then, I mean, externally, okay, then it will follow that classes. Otherwise, I mean, by default, yeah, it will follow the alphabetical order, like everywhere.
Sir, apart from that, what all means which all pre-processing we should focus?
Okay, whatever is given there, no, I mean, let's see whatever we have used in the, I mean, in those weeks. Okay, in the contents. Okay,
Mhm.
last, at the last I'll summarize. Okay, I'll try to make
Okay.
it think. Okay, but yeah, for example, see whatever we have mentioned, no, the questions will be most. I mean, more than 90%, or just expect 90% questions around these things only, like whatever we have covered. 5 to 10% questions
Okay.
can be from here and there. Okay, we can go a little outside from the, I mean, exact things which we have covered. Okay, so yeah, given the following code snippet that preprocesses a data set with both continuous and categorical features using sklearn and dot preprocessing tools. Okay, yeah, we have used min-max scaler and one-hot encoder. Okay, and yeah, we have used column transformer. For numerical, we have used min-max scaler, and categorical, we have used one-hot encoder. Okay, so it asks you to give X transform, but I mean here we have mentioned as 0. So it will talk about the first column. Okay, so in the first column, we which one comes? I mean, we will get these values, and we have applied min-max scaler. So basically, question is simply asking you. I mean, there is nothing to do with this one-hot encoding part. Okay, I mean, so we can ignore these steps. These steps. Okay, yeah, we have to focus because here we have mentioned as 0. So that's why we have to work on this part. Okay. So here min-max scalar, what it does or how it
Zero,
works?
zero means it will be the first row, right, sir? Not the first column.
Yes, sir, it's a row.
It's a column transformer,
It's
so
column
that
transformer, no?
0
In
will
column
be
transformer,
your
yeah,
0
So
first
then answer
column.
is not match, sir.
is it?
Yeah,
Okay.
yeah.
Yes, sir.
It's referring the
Yes, sir.
first row actually.
Okay. So okay. So what is first row here? Can someone say? I mean,
Yeah,
maybe you can.
in the sense like 2.0 comma apple. So how that will be represented? So that's what the answer is
So
actually.
first row is
Column,
0.25100.
First row
uh,
is point. Okay.
isn't that the column?
That's a 2D
So
array. So basically 2.0, 5.0, 1.0, and 4.0 are columns.
Exactly. No?
Correct.
The row is like the first entry, first list you have in that array. That is
Ah,
the row.
right.
Okay.
Hmm.
And you are using column transformer. So actually you are using columns based on that, right? By the name
So you
itself.
can even you can notice na num min-max
Hmm.
scalar on first one, first column. So
Numerical.
obviously we will not do min-max scalar on Apple, right?
Sir, here we have to just use the min-max scalar, compute the first value, right? That 2.0 what it will be, and then apply one hot encoder on the first column.
Correct. I think yeah. I mean, both of you are correct. So I think I took misinterpreted it here. Okay. So first of all, what is happening here is that first we are applying min-max scalar on first column. Okay. So this 0 simply represents this column. Okay. And yeah, this one simply represents the column. Okay. But after doing this, no, after doing this, you will get the values. Okay. And then when you are seeing the X transform, no, X transform is 0, no, then it is giving you the first sample. Okay, so how you are getting your first sample, right? I think yeah, this is what this is what it is happening here in this case. Okay, so what you have to do is that, so you have to give the how this, I mean, after this transformation, what would be the okay, how you will get this first sample, right? This is what you have to do here. Okay, and in this case, okay, maybe you can also run it. Okay, I'm cross check it by running the code. Yeah, I think yeah, this is what it this is what will be happening here. So for first sample, what will happen? I mean, for all these value, we are applying min-max scalar. So what will happen in this case? In min-max scalar case, what you will
X
get here
minus
is that,
2 minus
no,
1
max,
divided by
yeah,
5
1 by
minus.
4,
yeah.
0.25.
So it's in min-max scalar, basically x minus x minimum. Basically, you call it
Divided by X max by X min. X max
divided by
minus
x max minus x min.
X min.
This is what you will do. So for
Mhm.
this value, you can see that 2 minus minimum value is 1 and maximum value is 4, minimum value is 1, right? So
Sir,
1,
maximum is 5.
okay, maximum is
5
5.
minus 1.
Right. Maximum is 5. Okay, 1 upon 4, so 0.25. So that's why this 0.25 is coming from here, from this one, and then apple, banana, apple, and cherry is there. Okay, then when you will apply one hot encoding in this, no, then you will get this one, right? Because I mean, you will get multiple columns, apple, banana, and cherry. So there will be 3 new columns. Okay, so 3 new columns will be there. I mean, first one will represent apple. Okay, first one will represent apple. Then second one will represent banana.
Banana.
Okay, and third one will represent cherry. Okay, so since here it is apple, so that's why it will
Alphabetical
be
order.
1.
One.
Yeah, alphabetical order, right? So that's why
Yes.
0.25100. This is what you will get. Okay, yeah. So that's how you can solve it. Okay, yeah. I think yeah. I also missed to see that. Okay, I mean, yeah. Okay. So let's move to the question number 4. In question number 4, what is happening here is that we are applying. I mean, first we are doing polynomial. We have taken polynomial. We have initiated polynomial transformation, and then we have also taken uh, a PCA transformation. Okay, then we have taken PCA, and then in feature union we have combined both. Okay, I mean we have taken both polynomial transformation and PCA transformation, and then in the pipeline, yeah, after that we have scaled it. Okay, so what we are asking here is that if the shape of original x is, I mean, 20,640 column samples and 8 columns, then what will be the shape of x transform? Okay, so here, so what is the difference between, I mean, maybe in feature union and the column transformer, or I mean, yeah,
Column
Feature
transform
union
works
runs parallelly and
correct.
column
feature union
transform
and
works on each column.
Both runs parallelly only. Okay, and column transformer also. I mean, there also you see the parallel cases only. Okay, but here, what is that? So for feature union, no, entire column, original column is the input. Okay, and for, I mean, in column transformer, that applies on those particular columns which you have mentioned. Okay, you okay?
Hmm.
I think
Pipeline
someone has
applies to all, column transformer only
right, right,
applies to specific columns, huh?
right. And but yeah, in pipeline it is a sequential process. I think was there. I mean, someone. Okay, okay. I thought that someone message or someone. Okay, yeah. So in pipeline, I mean, you pipeline applies to the all columns. Okay, and feature union also applies to the all columns. But the difference between feature union and pipeline is that pipeline apply. I mean, pipeline you apply functions on a sequential basis, but in feature union everything applies on a parallel. Okay, but I mean between feature union and column transfer also works parallelly. But yeah, here I mean you apply particular function to particular column. Okay, that is there, but in feature union everything applies on entire column. Okay, so that is there, and you work on parallel. So what will happen now in pipeline, the input of first transformer, sorry, output of first transformer is the input of second transformer, right? That's how a pipeline works. Okay, but in feature union, I mean input is the entire data set. Okay, I mean entire column for both cases. Okay, entire original columns. Okay, not the, I mean,
you
pre-processed one.
mean all the columns.
Yeah, all the columns. Okay, see, or I mean that you can mention. I mean, it is possible here, but yeah, but the main thing which you have to focus here is that, so here you do not. I mean, okay, I mean the original data set, no, that is the input for both transformer. Okay, so that is there. Original data set or original columns are the input. Okay, but in pipeline that doesn't happen, right? In pipeline you okay, I think here okay, so in this one, in column transfer, what would have happened? So I mean original data set was the input here also. Original data set, original column was the input for both, but yeah, we took the, I mean that particular column, not the entire data set. Okay, or entire column. But in pipeline what will happen? I mean if let's say this is the first step, no, or I mean maybe yeah, in this question only we have pipeline, right? We have used it, no? Okay, I mean yeah, okay, we have used two things. Okay, in this one, no, let's talk about this one only. So here what will happen is that the output of this pre-processing, no, output of this will be the input of this one. Okay, after this step, no, then we will move to this step. So it's a sequential process.
Yes,
Okay,
sir.
but yeah, in feature union, I mean it is a I mean parallel process, and also the original columns, no, those are the input for both features, both transformers. Okay, so yeah, that's how it works. Okay, and at the end you combine everything. Okay, so in the polynomial transformation, okay, let's talk about this one. Let's say you have a samples like okay, let's say let's say you have samples like X, Y, and Z. What would be the, I mean, what would be the polynomial transformers of degree 2? Can someone say?
One x y z, uh,
X
and
square,
then x square y square z square.
Okay, X
X
square,
Y,
Y
X
square.
Z, Y Z.
Okay, and X,
So
Y,
there actually
Y,
one
Z.
way to, I think there is a way to kind of remember it geometrically. Like,
Okay,
tell
I
us.
mean, if that is there, just let us, I mean, just tell if you remember it.
So it is like just put x y z like side by side, and then just like if people remember, then it's
Okay,
okay.
okay.
But it's like that Vedic maths thing, huh? You just
Uh-huh.
do that straight up math, then cross, then triple cross, then double cross, then last cross, and
Okay,
then
okay,
that's
okay.
basically what you are going to get anyway.
Hmm. Yeah. So, or I mean, yeah, there could be. I mean, you can memorize using different ways. Okay, but yeah, here it's like a ultimately it's all about permutations. Okay, I mean, how many number, or I mean, not the permutations. Permutation will cover these parts. I mean, okay, degree 2 part. Yeah, or I mean, yeah, it is like permutations only. I mean, NP1, NP2. Okay, I mean, yeah, how many numbers of features are there? 8p1, 8p2, or something like that. Okay, since it's a degree 2, 1 plus 8p1 plus 8p2. So that would be the output. Okay, or otherwise, just instead of going to the any formula, just directly see it. Okay, so it's like every combination is possible. Okay, so here we have already mentioned include bias equal to false. So this term won't come, right? So for 3, what we are saying is that for 3 values, I mean 3 direct values, 3 degree 1, 3 degree 2, and which is the nothing but the square of each term. So 3 values like that, and this is nothing but 3c2. I mean, okay, I mean we are getting the combinations of 2. Okay, so that is there. So like this, how many values we are getting for I mean 3 samples? It is nothing but 3 plus 3 plus 3c2, which is nothing but I mean 3 only. So we are getting 3, right? So similarly for 8 values, what will happen? Okay, I mean since here we have 8 I mean 8 features. So first it would be something like yeah, I mean feature 1, feature 2, 8 values like this, 8 values like this, right? 8 plus 8, I mean it will be 16, and then we will have combinations like 8c2, right? Getting my point or not? 16
Hmm.
plus huh,
Sir,
8
we
divided
did
by
8C2 because degree is 2. Uh,
right degrees too. So
if
that's why
degree
we are just yeah.
if degree was 3, then we will do 8C3.
No. After this, no. First, we have to calculate up to degree 2. Then we have to calculate up to degree 3. Okay, and then again, yeah, we have to calculate the all x cube, y cube, g cube. So see, ultimately, what we are doing, the 3 plus 3c2 is nothing but 3p2, right? I mean in permutations. Okay, no, not like that. Sorry, I am just
It's
confusing you.
combination, sir.
Yeah, right. It's combination only. Okay, I mean, yeah. I mean, this doesn't matter. Okay, I mean the sequence. I mean, yeah,
And so we
sequence
have a
doesn't matter.
direct
Yeah.
formula for this.
Okay, so yeah, do you
N
remember it?
plus D, C D.
Sorry, what is the
N
formula?
And
plus N plus D,
n plus
choose
N plus D
choose D.
hmm,
to
minus
D.
one because bias term is false.
Okay,
Yes.
N plus 2 D plus to the power D, right? This is
Choose D, choose D.
Tuesday, sir.
okay.
N
So
plus A C D, मतलब choose D, the
Okay,
combination D.
Tuesday. Yeah, right.
And
So okay,
then
so
N is
okay,
the
I
column,
hope. Huh.
N is
Yeah, I
like
got
2,
your point. Yeah,
right? And then
yeah. So yeah, if I talk about the visualization part, okay, I mean, so I hope you are able to see in this example, right? Okay, I mean, obviously there is a formula. I think yeah, what he's saying that is correct only.
Sir,
So
can you
using
please
that
tell the
formula,
formula?
huh?
Can you please tell the
what
formula?
what if
I think they will write
interaction,
in the chat box.
if it
Yeah.
is interaction term
Ah,
is false, then it's better to actually know this, how we're expanding
ah.
this. Kind of
Okay.
not the
So see, if you want to see like that, I mean, if you want to take all the terms, no, here what is happening now? 8 were there for degree 1, then 8 were there for directly square values, so degree 2, and then there were 8 combinations, I mean 8c2, right? So that's why 8 plus 8 plus 8c2. Okay, I mean 56 by 2, it is nothing but 26. Okay, uh, not 26, 28 actually. right? 16 plus 28. So 44. Okay. So 44, columns will come due to this one polynomial transformation. Okay, here, yeah. From here, due to this, you will get 44 columns, and then you are doing PCA transform. In PCA, we have already mentioned column number of component equal to 5. So that's this PCA will give 5 new columns. Okay. So that's a 44 plus 5, total 49 columns will be there in your data set. Okay. So that's why you have in this case, no, okay, yeah. In this case, you have 49 columns, right? Okay. So like this, you can get
So
the
if,
answer of this one. Huh?
sir, if we have interaction only equals to true, that means the individual terms won't be taken into consideration.
Right, right.
Then
You can
expanding
ignore
the
that.
terms and then noting down the numbers would be helpful.
Yeah, yeah. So here only, we saw, no, the you have to just ignore that three value. X square, y square, z square, term. Okay, with that component, just ignore that, and yeah, you will get the answer.
Otherwise, the original XYZ will be there.
Ha ha ha.
Oh.
Yeah. So okay, in this one, question number 5, we are talking about label encoder. Okay. So
Sir,
basically,
just a sec. Like, if in the previous question it was
hmm,
interaction term false,
hmm.
right, not including interaction terms, then how would we solve it?
Okay. So in this one, no. Okay. So okay. For example, let's talk about x, y, z only. Okay. So what would be the let's say if interaction equal to false. So what would be the values? What would be the values? Just tell me.
1
So it would
XYZ,
be
XY, YZ, and
one.
XZ.
X, Y, Y, Z, X, Z, right?
Huh.
So this is what we did, no? See, this one component is there, this component is there. So X square, Y square, Z square component were there, no? What we discussed that. So you just have to ignore that term. So what we did, no? 8 plus 8, okay, 8 was for this one, for single term, degree 1. 8 was for degree 2. And then 8C2 was there. So you just have to ignore this part, right? Up to
Okay.
degree 2, it's easy, right? Yeah.
So there's somebody gave a formula in the chat. Is that valid?
Sorry?
Somebody is mentioning a formula in the chat. Is that valid, or is that like a
I also need
same
to
thing?
check. Okay, I also need to
Okay.
check. Okay. Okay, just cross check it. Okay, most probably I also need to cross check.
Okay.
Okay, yeah, I have been used. I had used these things. Long ago, no? So that's why I'm also not sure whether the is the correct thing or okay. Whether it gives the correct answer or not. Okay, but yes, since he's saying and yeah, I also I'm able to recall that there were formulas. Okay, it gives you the exact values. So just cross it. Okay. Yeah. So see in this question, okay, in second, fifth question ask you to give the, encode is, you have to use label encoder. Okay. In label encoder, as we know, what happens is that you will choose the unique values, okay, and you will make the column for that, okay, and for others, yeah, obviously, there again you will see that like 1 or 0, something like that, right? Right or wrong, at least still.
Sorry, sir, it was
Or
mute.
Sir, can you repeat?
yeah. So okay. So okay. Can someone explain how it will work? How you have to do this?
So
Can you,
label
sir?
encoder
Because
basically works on the alphabetical order. It will give the label. So
hmm,
your B will come first, then C, then D, then F,
B will
and it
comes
will
first.
integer values to those. So your B will
First,
be 0, 0. It will be 0, sir.
yeah,
Then
and
C will be 1.
C,
Then D will
correct.
be 2.
Hmm,
And then fish will be 3.
correct. So encoded data will contain only the values 0, 1, 2, and 3. So this is okay. So this one is correct. If elephant is passed to encoder dot transformer, it will successfully transform to an integer. Is it true? No, na?
No, sir.
Because yeah,
Label
yeah,
encoder will learn the encoding representation from the data. So data doesn't have this elephant. So how can it will return the
correct.
Mhm.
encoded value?
Yeah, so that is correct. So yeah, if this won't run, okay, label encode assigns higher integer value to more frequently occurring labels. So that is also
Oh,
not correct.
it
Not
works
true.
in dictionary format.
Yeah, yeah. So again, the fourth question says after calling encoder dot inverse transform, the results will be doc. Is it true?
Yes, sir, it's right because you can see that two maps to dock to an inverse transform basically returns the it's like transformation of the actual returns the actual value from the encoded value. But here I have one question. Inverse underscore transform should be there, na? It underscore is missing there.
Okay, where?
I mark that answer as wrong.
Okay, inverse. Okay, here no.
But
Okay,
answer is given as right.
right, right. Okay, yeah, that is the mistake here. I'm maybe because I mean it when they would have uh did it no. I mean when they would have set this in this format no, it was not able to process this one. Okay, that
Okay,
underscore.
okay,
Okay, it
okay.
is issue related to the latex.
Sir, wouldn't the last one be correct?
Yeah, that is
It's
correct
correct.
only. That is correct.
So what was being discussed later?
Okay, we were talking about that dot inverse transform. No, here underscore should be there.
Underscore should be
This
there.
is
Yes.
yeah,
Yes.
that is what. Okay. Yeah. Question number 6 is what is the main principle behind a dummy regressors prediction strategy? Predict the mean or median of the target variable for
Right.
all steps. So that is correct.
Yes, that's right. It
Yeah.
also means it also has this frequency, no, most frequent.
Yeah. Most yeah. I mean most frequent not for dummy regressor. I mean okay. So like that you are saying. Oh yeah. Right. Right. Okay.
I
That
am saying
option
for
is there.
dummy classifier, I'm asking. There
Right.
is
Right. Dummy classifier basically you use. I mean you predict the most frequent value.
hmm.
But yeah, you have this strategy. I mean, see, ultimately it just
Your
saves the
regressor is
baseline.
so mean and median will
Yeah,
be taken.
right,
So
right,
that's
right. So, which of the following scenario
this
demonstrates
I
a high
have doubt.
level? Actually, the question is not very clear. Okay, I mean here or maybe, but yeah,
That's why.
yeah.
Miss,
Which of
what
the
do you mean
following
by
scenario?
empirical error?
High empirical error. I mean, you can think it like a training value error. Okay, I mean training error. Okay, generally it refers to the
High
training error.
training error, but good
Right, right.
generalization.
Yeah, but potentially good generalization. Okay, something like this they have written. Okay, yeah. Here, so I mean, good generalization simply means I mean, what they are trying to convey. Okay, as I'm saying, the question's not very clear. Okay, it's simply what they are trying to say is that okay, I mean, out of these options, if we have to mark no, then it simply means that okay, I mean, the model is not overfitted model. Okay, so that's why
Hmm.
I mean, okay, from these things, what we can understand is that model is not overfitted. Okay, so let's see the options. A model that fits the training data perfectly and performs well on the validation data set. So this is not the case, right? So
That's
here,
overfit.
yeah, huh?
How, sir?
No, yeah. So see,
How, sir? Is it
here
because that we will not have any high level of empirical error in that case?
so here I mean if we interpret from here no, so if the
Hmm.
question itself is saying that I mean there is a high level of empirical error. Okay, I mean first of all the question is not at all clear. Okay, so that is there. Okay, ideally these questions are completely ambiguous. Okay, but
Hmm.
yeah, still if we have to attempt no, then
Hmm.
we are doing it. Okay, so first option
Okay.
says that a model that fits the training data perfectly. Okay, so I mean it simply means that I mean it
Overfit.
is the case. So yeah, overfitting. Okay, second option, a
Empirical
model
error
that
is low.
performs equally. Uh,
Empirical error is low, no? If it's
right,
perfectly.
right, right. Yeah, a model that performs equally well on training and validation data set. So this is also a case of, I mean, you can say that it is also case of
No
this
error
one.
is there.
Yeah,
It is generalized case, I guess.
haha. So yeah, so that option we have to mark. Okay, I mean, out of these four options, C option seems most
C is
appropriate.
the right
Okay,
one.
yeah.
Sir,
So
you
yeah,
see,
It is
yeah,
not
yeah.
the most appropriate. It is just opposite of what is there in the statement above.
No,
हाँ
see,
Yes.
a model that has low training error, okay, but slightly worse performance on a validation data. Okay, ideally, this is what we see, no? I mean, let's say in case
In
if you
general
get a
cases,
normal,
yes.
yeah, in general case, no, or I mean, if your model is not overfitted or underfitted, no, in that case, the error will be little. You will get error. Okay, but I mean, the error on training data will be whatever error you are getting on the training data, no, the validation
okay.
data
Hmm.
error will be little lesser. I mean, little more. Okay, validation error
The error is
that will
there,
be
but it
high.
is not too bad. मतलब it is high,
Ah,
but not too high. So it's like
yeah. But I mean,
okay.
instead of discussing on this ambiguous question, so yeah, let's ignore it.
Says too
Yeah.
ambiguous. It's really
What is
ambiguous.
this empirical error?
So usually we call it we refer it for the training error. Okay. We refer this term for training error.
Sir, I just googled it and it said it is generalization error.
Yeah.
Empirical error.
Hmm.
That is why it is written, but potentially good generalization. High empirical error, but potentially good generalization. The statement itself is contradicting.
I understand. So basically, I'm telling you, empirical, it's a completely generalized term also. Okay, I mean, usually whenever we are seeing, no, I mean, the error on training data. So for that, we can use this term. Okay,
Okay,
but
so
yeah,
like, training error and empirical error both are equivalent, kind of.
similar. Yeah, yeah, kind of. I mean, in general, we
Yeah.
represent it using this term.
Okay, okay.
But yeah, okay. Consider the following Python code snippet that demonstrates the use of standard scalar from a scalar. Okay. So these are the there. So standard scalar, I hope you all know that mean should be 0 and standard deviation should be 1. Yeah.
B
So that would be,
option.
Yes, B.
yeah. Okay, B option. I standard the feature in the data array to have 0 mean and unit variance. Yeah. If the, I mean, yeah, mean and variance are common. Yeah, mean. Not mean and variance and standard deviation. Yeah, this is just a square. So let's move to the question number 9. So it says, I mean, yeah, you have to use the polynomial transformation of degree 3. So again, yeah, x square, I mean, that square term won't be there, and only the combinations term will be there.
Just combination terms will be there.
Right, right. So yeah, for okay, they want for all. Yeah, for both samples. Okay, so
B.
for one, okay, for first one will be there, and then
Hmm.
we have 1, 3. So this
Then
is degree
3,
1.
then 1 into 3.
The yeah, degree 1, and yeah, I hope since you all know that you will be able to do.
Sir,
But
but B is the answer.
okay, so is it? I think B you will get for degree 2, no?
Yes, that's my
Yeah,
question. Means like why we are
yeah.
getting for degree 2?
No, no, no. It
Degree
will be,
3.
yeah. I think, yeah, there is some mistake.
We
You will
should
get
have
the
like three. Means like 1 second, sir. There are two features, and we have 3 degrees. Degree has 3. So how to get the third one?
so, for third one, again, you have to get all the combination x, y,
Interaction
z.
is equal to
Yeah.
false, then we will get the third one.
Uh,
Huh, yes,
So
that's my question.
by the formula we can second option is correct. 3 plus
Huh,
2
by the formula it's
6.
correct.
okay, okay. Let's just see. One, one. Then 1, 3 is there. Then 3. Okay.
3
Okay.
into 1.
Then yeah, one combination is 1, 3. So that will be 3 only. Okay. And since Z is not there. Okay. Uh, just check.
After
I
that,
mean,
how to get degree 3? We can't get, no?
yeah. So I mean, anyways, I think the both will give you the same values only. Because for, I mean, if interaction equal to only equal to true is there, and for degree 3
No, sir,
also like
degree 3 will be there, no? So
yeah.
we can
So
use
I'm
the
saying
power term.
Sir,
just see. Yeah, power term would be there, no? The interaction only equal to true is there.
sir,
Huh,
here
but if
we
it is
can
false,
directly use the formula and check.
Sorry.
Sir, here we can directly use the formula and check.
Yeah. So that formula, I mean, that formula we are not was not giving. I mean, if you are using okay here, I mean that formula here you don't have three terms. First, of all. I think okay. It depends it whether it throws an error or I mean it runs. So
It
most
is
probably it would have run. It is running, no?
yes,
Sir,
because
just
we have 10 elements at the last, and that is what we are getting 2 plus 3 C3. That is 5 C3 is 10. So C, if the answer C is correct, so we have 10 elements.
Let's write it now. Or maybe that will give us the better clarity. Okay. I don't know. I mean which node it will open. Okay, let's stop.
interaction only is true means
So
All
what I
of
am
degree.
assuming, no, after this degree, since you have two columns, either it should throw some error, or I mean, it should, I mean, after all that, after degree 2, no, for each degree, it should return the same thing. Okay, this is what I'm assuming. I'll just cross check it. Okay, I mean, in the note.
I think
Just,
answer is right only, but
yeah, yeah.
must check.
So this is what I'm saying. After degree 2, no, for each degree, it will give you the same answer. Okay,
But if
yeah.
it is it's like not running, then all the answers are wrong.
Not all the answers. I mean, answers for this one only, no?
Yes, sir.
Why all answers should be wrong? I mean.
because it will return an error, so we can't get that
Okay,
output.
okay, yeah, oh, okay. For this particular question, I thought something else. Data like 11324. Okay.
I don't know why I'm getting confused. I was talking about this a few minutes back, but I'm getting confused with interaction only. It is
Okay.
true and false. What happens? Like, what was the difference? Like, I just
Yeah.
forgot.
In
So
true, you will not have power terms, while
Yeah.
in false, you can have power terms.
Okay. Okay.
so yeah, that is there.
Yes, so then B is correct.
Yeah, yeah. So I'm just cross checking whether it will throw error since you have just two terms.
Yes,
Okay, and you we have just two terms, and yeah, still we are for degree three we are getting the answer. Okay, whether we will get the answer. Okay, we'll see just how these codes are working. I mean, whether they will give the answer or the same thing which we will get for degree two also.
mhm.
Okay, okay. From SQL processing. There
So
should
it should be
not be a
capital
poly.
polynomial features.
Yeah, okay, okay. Just features. Okay, capital is there. I think it should have been a long time since we are using. I mean, yeah, this one. Polynomials features is there, no?
Capital P. So is
Let
it
me.
capital P?
Okay, okay.
Hmm.
It should be capital only. Right, right, right.
So just connect it. You will get your suggestions
Ha
also,
ha ha
right?
ha.
Or
Okay, okay.
that
Yeah.
will
In the
help
meantime, yeah.
you, right?
Right. In my laptop, this line is not work. मतलब
So we'll write degree equals to 2, interaction only equals to true. Degree
yeah.
equals to 3.
Degree
Okay, okay.
3.
Let me write interaction only, right? Just check the spelling.
Underscore only.
It's coming as
So degree equals to 3, can you do?
Okay, okay. Yeah. Just we will do for degree two first, and then
a. Hmm.
after this we will check the. After that we will check for degree.
Sir,
So there will
import
be a comma.
is, can
Uh
you
huh.
remove?
Polynomial features degree is equal to 2 after that.
Okay, comma here, no?
Uh,
So
Yeah,
also,
yeah.
when we are importing polynomial features, we are writing, but while initializing it, we are writing feature. So can you
Okay.
remove an S from above? How is it?
What are
Okay.
you saying? I
S
don't
is
know.
so
Polynomial features will be there in the second.
So I mean, is there anything else
You have
here?
written polynomial feature, not features.
the second equal, second line.
PF equal to sir.
Okay, here. Okay, okay, okay.
Yes.
Thanks. I think I hope the spellings are correct only.
Yes, yes.
Yeah. So here for degree two also we will get the same thing, and after this one for all degrees we will get the same values only. Okay, I mean same thing, right?
Hmm.
This is what we are seeing. So it depends completely on the function. Okay, and yeah, for all the degree after two, no, you will get the same values because we have just two terms,
So put it 3.
right?
Put it 3
Yeah.
and interaction only
For
to
all the
false.
values, yeah, you will get the same thing.
No, no, interaction only to false.
Okay, okay, okay.
Just want to see the output.
Hmm. Yeah. In this case, basically you will get the square term will get added. Okay, that square and cube term will
Hmm.
get added. But yeah, they won't throw any error. Okay, for that one.
Okay, okay.
Yeah. Okay.
So I think the third one will be the answer for if interaction only is equal to
Equal
false.
to false. Right.
Can you show the collab file? Mm,
Yeah.
do the do true for this.
Okay. So I mean, it will give you the same answer which you will get for degree 2 also.
So
Okay,
Can you
degree
explain the
2 and beyond it will be same.
same, right? Yeah, this is
Okay.
what I'm. Yeah, this is what we were talking earlier also. Okay, we just wanted to check whether it will throw some error or it will give you the same values. So yeah, it
So
is
can you
giving you the same.
explain the output ones?
Yeah, so see, output is like, see, you have to get the, I mean, first you got the bar system, okay, which is 1. Okay, then you get your original value x and y. Okay, so which is nothing but here 1 and 3. Okay, and now after this you will get the interaction term. So here only one interaction there, x and y. So it is like xy, which is nothing but 1 into 3. So we are getting 3, right? After that we are not getting x square and y square, right?
So sir, it won't be like x1, x2, x1, x2, x1 square, x2, x2 square, x1.
Yeah, so for degree 3 you will get x1 square x2, right?
That will be 5, na sir.
Yeah.
Then it
uh,
won't be 4
uh,
then.
Sorry, I meant to say, I mean, if interaction is only equal to not, I mean, it is not true. Okay, then in that case you will get that, no? So interaction only equal to true means you won't get the higher order term. Higher order term means, I mean, that is square bar term. Okay, so that term won't be
Okay,
there.
so x1 square, x2 and x2 square, x1. These both will want. This both won't be present.
Yeah, it won't be present.
Okay, I thought like x1 square, x2 square, x1 cube and x2 cube. These only will be removed.
So see, for degree 2, okay, I mean, degree 2, you have this value, right? Right? For degree 2, you have 1 x xy, right? X1 square won't be there. Okay, I mean, x1 square, or yeah, the square term won't be the higher order term won't be there. Degree, I mean, interaction only equal to false means, okay, I mean, the higher order term will be there. Interaction only equal to true means you have to take only the interaction terms. Okay, x y z x y, something like that. Okay, you maybe you, I mean, later you just open it and just try out different combinations. Okay, I mean, here, I mean, this was not the ideal case.
Degree equals to 1 will not have any transformation, right?
That won't, I mean, yeah, there won't be any comments. It will be simply 1 x and y. Okay, so that will be there. Okay, let's move to the question number 10. Question number 10 says, I think, yeah, there is a relationship between W2 and W1. Okay, and now you have x values and y values. So you simply you can make equations like this. I mean,
Sir,
something.
can you just like if there are two features like x1 and x2, so what will be these four values? Can you just state once?
Yeah, x1 and x2, no? 1, x1, x2, okay, and then x1, x2.
X1, x2, and x1, x2. But there are four
No,
terms.
no,
No?
not x1, x2. I mean, 1, x1, x2, and then x1 going to x2.
Okay, okay. So the intercept
Right,
will be included. Yeah, got it.
right. Okay. So let's move to the question number 10. Question number 10 simply ask you to calculate W, I mean, yeah, the value of, I mean, W1. Okay, not W0, not W2, W1. Okay.
Sir,
So this is
the way we have to see like B in the previous question has to be like a column wise.
okay. Here, okay.
Has
So
to be seen
it's
column
like,
wise,
no,
right?
no, no, no. It's like a, see, first row is the first sample, second row is the second sample.
Okay.
Yeah. So first you have to work on 1 comma 3.
Okay.
Then you have to work on 2 comma 4. Okay.
Okay.
So do not get it every time. No, the samples are like this only. First sample, second sample. Okay.
Okay.
That's why to, I mean, to understand it better. So we are giving you in rows. Okay. Otherwise we have kept it in a same column. No.
So can you
I mean,
convert the first one to the answer in B?
sorry, I didn't get
Like
your point.
1 3, how is converting to 1 1 3 3 in terms of like X Y which we have?
Yeah. Again, I'll tell you same thing. Let's say you have x. Okay, x and y.
Hmm.
Then okay. Then after degree 2, no. After degree 2, you will get as 1. Okay, all right. Since we have right, uh, just give, just, yeah. Okay,
Okay.
yeah. See here. Okay, so here you got 1 x. Maybe I right.
Hmm.
Let's say you when you have degree 2, no? Then in that case, you have 1, x and y. Okay, for degree 1, okay? This is the bias term, this is the, degree 1. When you have degree 2, 1, x, y, okay, sorry, x, y, okay, that is there, then x square and y square. If interaction only equal to true, no, then you have to ignore these two terms, right? This term won't be there. Now let's see for degree 3. For this case here, so we are seeing 1, 1, okay, 1, 1, then 3 because of y, and then xy, for due to xy, 1 into 3, 3. Got it? For let's say for this one, no, second sample it will be easily visible. 1, then x, which is 2, y, which is 4, then xy, which is 2 into 4 equal to 8, right? Yeah. So that's how you will get the values. Okay.
Now it is clear.
Yeah. Let's move to the next question. Okay. In this question, what it says is that, so here you have w1 equal to, okay, okay, you don't have w1, okay, but
Sir, can
we
you
know,
solve this question?
okay, I'll do that. Okay, so here what you have to do is that for first sample, no, since it is 0, 0, so let's ignore this sample. So for second sample, no, let's write the equation. So it's the equation, see, the function is something, since intercept equal to false, no, so that's why equation should be something like this one: w1 x1 plus w2 x2 equal to y hat, or maybe I can write it, right, that would be the equation, no?
Okay, sir. Plus E.
Sorry.
Plus E. There is eta, I guess, at the
Okay,
end
so
of the
yeah, so
equation.
okay, yeah, so that error they have already set it as 0, right?
Okay, so we don't have to worry
Yeah,
about that.
yeah, we don't have to worry about
So
that. And
that is intercept, right?
that, that is error. Okay, they have written the equations, okay, and then see that also that you will write when you are writing y true, not y predicted. Okay, because like for y predicted the value is exactly equal to this equation, no? For y true, no, then you have to include the error term, right?
And
So
then
that's
where
why
is intercept here?
intercept is not there, no? So w naught, okay, ideally when you have to take the intercept, no, see in the formula we have, you're writing intercepting fit intercept or equal to false. If this w naught term, no, this indicates your intercept term, okay, because x naught is not,
Then what is
you don't have any value,
present, sir?
okay, so this term simply represents your intercept term, okay.
So
Sir,
x
Sir,
naught
But yeah,
is what? What did you
X
x
naught is
say?
naught,
what?
huh, okay, is there anyone saying something?
X naught is what?
Okay, here, no, what happens, no, that like this we represent your, generic equation, okay. So x naught don't carry the any value, or you can say x naught equal to 1, okay. X
Okay.
naught is nothing but the 1, okay, so that's why you will get w naught as your intercept, okay. So
So
generally,
x naught is always 1.
right, okay, for generic equation, okay, this is the generic equation, okay. So let's say you have a, maybe I should show it like this. Let's say you have one sample, okay, maybe for this one, okay. Let's say house status it room, or maybe I won't go that deep. Okay, yeah. So what happens, no? Let's say you have to, whenever you have to predict something, no? Why predict? Okay, whenever you have to predict, then based on the, let's say your column one is this one, nothing but the column one is your, okay, column one is, okay, column one, column two, column three is there, right? Okay, these three columns are there, these three features are there, okay. Then when you have to predict, no, so what you will do is that you will take first sample, let's say you are representing intercept as w naught, then w1 x1, w2 x2, okay, and w3 x3, okay, like this. This is your, that's using this formula you will predict always y value, okay. But if you have to write it as a original y value, then you have to include the error also in this side, right? If you are writing instead of y height, if you are writing y value, okay, then you have to include error value, okay. So in this question, since it's the original value, y error value, we are already saying that it is 0, so let's ignore this one, okay. And then we are saying that here we can say fit intercept equal to false. So this term won't be there. Okay. So now the equations are like y equal to w1 x1 plus w2 x2, because we have only two, two columns. Okay, 0 0 or 2 comma 1.3. Okay, so this is the equation we are getting, right?
Hmm.
So yeah, so let's put different values here. Okay, and from here only, like we can see w2 is nothing but 5 5 by 7 w1. So simply means w1 x1 plus w2 is nothing but 5 by 7 w1 x2. Okay, this is what we are getting. So y equal to nothing but w. Okay, we can write it like x1 plus 5 by 7 x, right? So this is the
Hmm.
equation we are getting. Okay, let's take for this one. Okay, which is nothing but for this one, what is the y value? 1. 1
One.
equal to w1 upon x1 value is 2, 5 by 7 into 1.43. Okay, yeah, just solve it. Okay, you will get the same answer. Okay, somewhere I think 0.3. Okay, so it will give you the w1 value. Okay, and this is what the question is also asking, right?
Sir, we have
So
to divide by one.
1, yeah, obviously. So here
One
this
by that
side, yeah,
value will give
yeah,
W1.
you have to get the 1 by this value, no? 1 by this
Hmm.
value.
That's what
Yeah,
I'm asking. Yeah.
right.
Okay.
So that's what, then only you will get w1, no? So that you have to do. Okay.
Sir, means we can put any point from this extent and get
Uh-huh,
W1.
you will get. See, the all the points are just double. See, two here, two is there, so here one, here four, then here two. It's they are exactly they have given you the equation. A complete linear equation, right?
Okay. Okay.
Yeah. So
Sir,
that's why
what?
the error is 0. Yeah.
Yeah, one thing on this question. So I was the approach what I was trying is they have given x and y. So I was just trying to construct x transpose x, the whole inverse x transpose y to
Uh,
find the weak vector.
sorry, sorry,
Okay.
sorry. Okay. Did you understood, or I need to hear what you are saying properly?
Hey, isn't the first term 0?
First term is yeah. First term w naught is 0, no? W
Uh,
naught is 0. Okay, but here okay, the w naught is not the coefficient, that is bias, no,
okay,
or
okay, okay.
intercept. Okay,
Uh,
coefficient is the w1. Okay,
Yeah. Yeah. So,
for
so
that,
So because fit intercept equals to false, we are excluding W naught X naught and here Y of 0.
w sorry, yeah, we are ignoring this w naught x naught, because see, because as you said, because fit intercept equal to false, right? And x naught was nothing but the 0 only, sorry, 1 only. X naught simply represents 1. Okay, because your column starts from x1. Okay, x1 x2, all the values are there. So this is, this is a way to represent bias term or intercept term. Okay, nothing else.
Sir, but then the 0 0 that you have removed have you removed it because it was 0
No, no,
or
no, no. If you will put the 0 0 all zeros, then you will, whether you will get the w1 value. Let's
okay, yes, so that
discuss
was
next.
0
Yeah,
0.
yeah,
That is why it is removed. Otherwise, when it'll
right,
have
yeah.
some value, we'll consider that.
We, yeah, we can use any values from here. Okay, or maybe for example, so they are giving you this relationship. Even they won't give you this relationship, no. Okay, then yeah, the solution is not possible, because all the values are following the same pattern. Otherwise, also you will. I can create this question in such a way that even without giving this relationship, still you will be able to get the answer of w1 and w2, because two equations, two values. Two equations, two variables are there, and two equations are there. You will be able to solve the questions, no?
What
Get the
is this
values of.
coefficient of 0? What is the value? How to calculate coefficient of 0? W1 value I got. What is coefficient of 0?
Coefficient of 0, I'm not completely not getting your question. So what you are asking? Coefficient of 0, what does it mean? This is your
The
sample,
pin
no?
statement. The pin statement, sir.
Uh, Sorry, which one? Which one you
Last
are saying?
statement she is asking.
So this one. Okay, okay, okay. So you are talking about print statement. So print statement simply says that, let's say you got some coefficient, no? So in coefficient, you have to get the first coefficient value. First coefficient is nothing but w1. Okay, it will return w1 value.
Okay,
Getting it?
got it.
Yeah, because like we are asking you to, see, range dot coefficient and range dot okay, I mean the what range dot coefficient will give you the list of list of coefficients. Okay, so first coefficient is nothing but w1. Okay, second coefficient is nothing but w2. Okay, even if you have saved a feet intercept equal to true, no, then in that case, I mean this will give you the w1 only. To get the intercept value, you have to use range dot I mean intercept, right? So I mean coefficient, you don't get that intercept value. Okay,
Okay, okay, got it.
yeah. So see, if these basic confusions are there, no, I would always suggest you to write this code and just check it on your. Okay, I mean, that will give you better clarity. Okay. In the sessions, I mean, it is little. I mean, yeah, you will see whatever I am showing you. Okay, so that is there,
Uh,
and I whatever I will show, that will be a generic solution. Okay, I mean, yeah.
Sir, I mean, whatever you explained, I understood that. Okay.
Mm.
But I was just trying a different approach. I just wanted to understand how do we handle that. So before that, what I tried is I just tried to write this code in Colab. Okay. Then we got the intercept. I mean, the code snippet that is given here, right? So we got the coefficient and all, so which is actually matching with this range. Okay.
Mm.
So I was trying to apply the linear regression formula. Okay. So the way to find the weights, W equal to x transpose x, the whole inverse, x transpose y. Okay, I was trying to find that product. Okay,
Mm.
so when I do that x transpose x, the resultant that is coming is a singular matrix. Okay, so
But,
because it is singular, we could not find the inverse of that x transpose x. Okay,
yeah.
so how do we handle that case? I mean, is that a correct approach what I was doing, or is it?
But no, no. The thing why you are getting like that in the matrix, no, because all the values are just a multiple of this one.
Yes, yes, these are
Right, right.
independent. Yeah,
Yeah,
correct,
yeah. So that's why you are getting like that. Okay.
correct.
Otherwise, yeah, that one.
Okay, so in that case, like, how do we approach this? Like, I mean, I should take only
This
the. I mean,
question, okay, this
if I have to
So
find,
can
this
you hide that? Like stop sharing, hide. Can you hide that part?
okay, this one. Okay, yeah.
I mean, if I have to use that approach of x transpose x, like, should I take only the independent values in the x? Then would that?
Yeah, otherwise, I mean, that will make you the your row is will column, so then determinant will be always zero, no?
Uh, uh,
I mean, yeah, the
so
determinant will become zero.
should I take only
Huh.
the first two rows? Will that work then?
Huh. I mean, in that case, no, even okay, I mean, in the proper, I mean, MLT approach, if the values, I mean, that will help you when you have some real cases. Okay, I mean, this is a completely a generated cases. I mean, we have generated these data points in such a way that you, I mean, directly you can solve it. Okay, I mean, once you understand that, I mean, linear regression formula, you will be able to solve it. Okay, so that's why we have written it like that. I mean, we have given you the point. It is nothing but the equation of a line. I mean, complete and straight line, not even the, okay, because all the point will fall, okay, and not, yeah, like this only, like
Okay,
0 0 or something.
okay,
That's
okay,
why.
fine, sir. Yeah, okay, thank you.
Okay, let's move to the next question, or I mean, anyone else has the doubt in the last question or any other doubt? All right. In question number, yeah, I whatever I said, no, you like this. See, always in linear regression, no, basically what you try to do, I mean, what this algorithm tries to do is that it just simply tries to fit a linear, I mean, equation formula. Okay, it simply always in linear regression, you always try to fit a linear equation formula. Okay, I'm linear equation, not the formula. Yeah, you always try to fit a linear equation in the between these points. Okay. So yeah, and yeah, and basically there would be, if the points are not completely, I mean, in a straight line, no, then there will be some error term. Okay, so or I mean, yeah, for example, let's say one thing I can do here is that instead of writing y trend, if I write y predict here, no, and then I can use any values here. Okay, okay, and then even if I don't give you this, no, then still you will be able to make a equation, right? Getting my point, or I mean, just confusing you guys? What?
Sir, what,
Huh?
how
Yeah,
to
please.
create equation if you don't give the point? It's just a random equation or what?
What I'm saying is that, so see, ultimately, let's say, okay, just go to the basics first. let's say you have points like this,
Mm-hmm.
you have to predict. Okay, so you trained some
Mm.
model that basically what linear regression model do works.
Getting a straight line as close
it,
as
it
possible.
tries
We'll
to predict.
solve the set of equations.
Ha, sorry, what did you say? Just say again. I think someone said something. No.
Sir, in this, the sir, wherever the equation is not given, we'll put it in the form of the equation and then solve for the equations.
Correct, correct. Yeah, you have to solve. I mean, you have to put it in a form of equation. You have to solve that equation. And in case if this is y predicted, no, then error term is not required, right? Because see, ultimately, what you are doing, no, for each point, no, how you will predict the value of this point will be where it will lie. Y prediction of this point. Let's say this is your line. Okay, I'm understanding that the ideal line should pass somewhere from here. But let's say this is the your line. Okay, this is your y prediction line. Okay, yeah, y hat. Okay,
Y hat.
yeah. So where would be the y predict value for this point? It will lie on this line, no?
Perpendicular to that particular line.
Right, right. For this point also somewhere here. For this
Mm-hmm.
point also somewhere here. So error term will be always 0 for y predicted line.
Yes.
Yeah. So this is what I was saying. Even if I don't give you the error term and I simply give you y
Mhm.
predict value, no, then you
Then
will be
also
able
we
to
can get.
yeah. Then also you can solve it. Okay. But yeah, if I'm saying giving you y train value and I'm not giving you error value, no, then there is a
Mm-hmm.
high possibility that there won't be any error. Okay. Okay. I mean, if I'm not writing like, uh, yeah. Okay.
Okay. Actually, I
Otherwise,
was
yeah.
confused with that X naught because there was also plus E. So
Okay.
that X
Okay.
naught
Okay.
where we are getting that was the
Okay.
confusing part.
So see,
Rest all
I
I
mean, this is
understand after.
yeah. This is a way of representation. Some people will represent it like this. Okay. Y plus W naught plus W1 X1
That's
plus
how I
W2
represent.
X2. Some people will represent it like this, and there will be few people like who will represent it. I mean, instead of writing is W naught, they will write it W naught X naught. X naught simply represents one here. Okay, it simply includes
Mhm.
the bias term. Okay, I mean just to represent that using
Okay, and that eta represents the error term, right?
error. I mean, yeah, in original prediction, no, I mean original value. So because this
Mhm.
is the this is what you are going to predict.
Hmm.
Okay, it is nothing but this, no. I mean, ultimately you are writing y equal to y hat plus e error,
Yes,
right?
yes, yes, yes.
This is what you are
Hmm.
writing. So that's why
Hmm.
y hat is nothing but this value, this part, and error is
Understood, sir.
nothing. Yeah.
Understood.
All right. Let's move to the next question. Okay.
Next is, I think, confusion matrix.
Hmm. Can someone say what is the formula for precision score? What is the formula to calculate the precision score?
TP
True
by TP
positive.
plus FP.
Exactly.
Ah,
What would you say?
true positive upon true positive plus false positive. Okay. Let's
Yes.
revise. What is the formula for recall?
Sir,
TP by
same
TP
thing.
plus
FN instead of F.
Yeah. Instead of false positive, it is false negative, right?
Uh,
FP.
So here, I think many of okay. I mean, let's give the chance to others also. Okay. I mean,
okay,
don't
sir.
know how many people say that. Okay, 24 people are there. Yeah. So, can someone say? I mean, someone who are, I mean, who has not spoken yet, how to calculate this precision score? Here we have three classes. Okay, how to calculate that? Precision for class one, right? So first thing is that true positive is there. So true
So
positive
last
for
class you gave a very,
yeah.
so last class you gave a very good way for the representation of 3 by 3 matrices.
Okay.
Yes, sir. Not one and one, that thing. I only asked that question.
Okay. Okay. Other I okay. I mean, at least one of you will answer no. I mean, I will be satisfied that yeah, you guys are understanding these things. Okay. So for my satisfaction. Okay. Yeah, 4 would be there on the top. Okay. And what
Sir,
about yeah,
true positives for class 1 would be 2, no, sir?
Yes, sir, too.
Yes, sir.
for class?
Too.
Yeah, right, right, right. My bad. Lack of focus. Yeah, 2, right? So that is 2. And what would be in the bottom?
Sir, 2 plus 6, 8.
Vertical, we have
2
to sum
plus
up
2 plus
4 plus 2.
Okay, go one by one. Yeah. What would be there?
8.
It will be 2 plus, and inside the bracket for false positive, it will be 3 plus 2 plus 1 plus 2.
No. False positive is it is predicted as positive, but it is not, right?
Just be, just come up with one answer.
Sir,
That
Yeah.
entire column, sir. No,
sir,
Hmm?
the
the
entire
prediction
column,
column
middle column,
2
like
plus
the
4.
entire middle column.
It's 2
This one,
by
because this
Yeah,
is
it's 4 plus 2.
4 plus 2
4
plus
plus
2.
2, 1
2.
upon 8.
1 upon 8. 2 upon 8.
I mean 2 upon 8, right? Because see, all these values are positive only because predicted as 1. So these column simply represent all the values which we have predicted as 1. Predicted as 1 means I mean positive class for class positive for class 1, right? I mean we have predicted these values for class 1. So it means these are the positive values. I mean this one is true positive and these two are false positive, right? So ultimately 2 upon 2 plus 2 plus 4, right? Which is nothing but 2 by 8, which is it will I mean when you will do it, you will get 1 upon 4. 1 upon 4 is 0.25. Okay. So yeah, that you will get the value for this one. Let's move to the next question. Question number 12 says, consider the following code snippet. Okay, we'll go quick. Okay, maybe yeah. Okay, question number 12 says, okay, here first option says the logistic regression model will give equal importance to both classes in an imbalanced data set. Is it? What happens
No,
when you set class weight equal to balance? Can someone say what happens
one
when you set?
by one by the frequency count of the classes.
Correct,
Which
correct.
is the higher, it
Hmm.
gives that a lower
Ha.
weightage.
Right. Whenever you are using class weight equal to balance, then it simply does that. I mean, it simply it multiplies. I mean, basically it is inversely proportional to your class frequencies, right? In your input data. Okay. So like that it works. So yeah, that is not true. The model does not use regularization because the parameter is set. C parameter means you are using regularization. So option B is not correct. The model will perform equally well on both imbalanced and balanced data sets due to class weight parameter. So yeah, that is not true. I mean, it will perform
This
equally well. Yeah.
right.
Then yeah, option D, the value of C indicates that the model will apply a regularization. So yeah, that is true. Okay. Here, after training a logistic regression model, okay, here only just see
That is true.
model.coef. This will give you W1, W2, W3, and model.intercept, it will give you W naught value. Okay. So yeah, after training a logistic regression model from SQL and which of the following attributes give the coefficient of features in the decision function? So yeah, that is really model.coef. Okay. So yeah, in perceptron, okay, I mean using perceptron, you have to predict the level of this one comma one. Since it is exactly a sample from your training data only. Okay. So from here also, I mean you can get the
Mhm.
idea. Okay. Otherwise, yeah, you can do the solve that proper. I mean mathematical.
So we
See,
have to plot now for that particular question. Means if
haha,
we don't want to just
right,
get
right.
the
I mean
that,
manual solving means that only. Okay. Manual solving. When I'm saying manual solving, it means yeah, right. I mean write or
Sir,
denote
means
all the points and
doing it.
yeah,
Sir, would you
yeah.
like to solve this one, sir?
Sorry. See, basically, what you have to do now, I mean, whatever
Sir,
you have
plot
learned
it
in
and
MLT.
then see which.
This is 0, 0. This is your 0, 1. This is your 1, 0, and this is your 1, 1. Okay, somewhere here. All right. Yeah. So basically, for all these points are for these points you are predicting it as a class 0, right? For these points you are predicting as a class 0, and for this point you are predicting as class 1. So there should be some line, okay, which is I mean there should be some decision boundary which is able to do this job properly, and then based on that decision boundary you have to decide. Okay, and this decision boundary, I think, yeah, you have to iterate it. Okay, after taking the, I mean, first you write it like that and just see whether it is working properly or not, or for all the points. If not, then just do the improvement. Okay. So
so
yeah,
we end when we have correctly classified all the
correctly
points
classified all the points.
based on our labels.
Right. and then
Okay.
you have to do it.
Yeah, based on that y value, right?
Right, right.
So
Based
like
on that y
we
value. So ideally, I should.
plot
Huh?
the x points, and then we see if we can kind of do this.
Yeah. So basically, so whatever training points are there, no, based on that, you have to select that decision boundary. Okay. Or that line. You have to fit that line in such a way that it is able to classify all the data points, all the training data points correctly. Okay. Once you get that point, okay, after that you see, okay, your point is like on which side of that line. Okay. So that's how perceptron works. Okay. And then yeah, in this question, so it asks like what does this predict dot predicts? Okay, in the concept of corridor, what does information the contain? Okay, it simply predicts the class. Okay, I mean predicts the class of the new data point. It's a direct question. Then yeah, in this
No, predict
question,
probability.
yeah, yeah, it predicts probability actually. Yeah, so I think yeah, it just said the predict class. No, it predicts probability only. Okay, so that's why I mean probability term is there, right? It simply
Sir,
predicts probability.
even in the last question, it will be directly one only.
Huh?
Like, do
Sorry.
we even need to plot it in the last question?
But yeah,
No.
this is what I said. No, I mean you can directly say that it will be one only. Okay,
Okay,
directly this was from our training data.
okay.
So what is
Yeah.
this posterior probability for the new data points?
Again, then just go to max stats concept, max likelihood function and all.
Okay,
Right?
so
Yeah.
okay,
From
that is
there
the
this
probability.
comes.
In simple
Yeah.
terms, it is
Yeah.
just the probability after getting the truth, knowing the truth.
Hmm. Correct.
Hmm.
Earlier, you have some probability, but now you have to verify it. Once you have verified it, then you can use that to say, yes, this has been in, means the dependence is there. So based on that, your probability will change, and that's Pasteur probability, that base theorem, if you know. So that's the thing.
See, you have prior, you have max likelihood, and then you decide whether your initial things were correct or not. That is what I think I'm going to say. Yes,
Mhm,
okay.
that
Yeah.
also.
Yeah.
So this question.
Yeah, you are working on a binary classification problem where the data set is relatively small and you suspect that a linear decision boundary will work well due to distinct class imbalance, distinct class separation. Okay.
Question.
Additionally, you want to perform logistic regression with L1 regulation for improved feature selection. Which solver is the most appropriate? Directly in the skeleton, there is a page. I mean, there is a table mentioned where, I mean, let's say you have logistic regression, you have a smaller data set and L1 regulation. Not all the solvers supports L1 regulation. So just see, I mean, what I would say. Okay, maybe
So remembering all them of them are
no,
required.
there are not so many things. I mean, these are the smaller things. Okay, I mean,
Yeah,
as I said, no, I
L1
mean,
works
we
with all, right?
yeah,
Sorry, L2 works with all. Sorry, L1
yeah,
or
L2 works with all.
L1 works with few only.
uh,
Hmm,
linear and that
right. And
sub.
then you have to see for which one is there for a smaller data set. Okay, I mean, which one can help you even in a smaller data set. Okay,
Mm.
so yeah, like that.
So can you show that table? So can you show
I
the
mean,
table?
you can okay, you can also search it. No, I mean, in SQL, no, I mean, when you will open this logistic regression, no, there you will see it. Okay, just switch to
Sir,
the
how we
stable
are
version.
canceling that particular to arrive at the answer?
Okay, okay, then let's move
Like
one by
there
one.
are two where L2, L1 regulation is allowed.
So okay, additionally, you want to
SGD
perform
is for
logistic
large
regression.
data set, I understand, so
Ha,
we
ha.
can remove that.
Okay,
LBFJS
regression,
will not work with
logistic.
L1 regulation, so remove. Newton's easy and how you're means checking between
Okay,
Newton's.
L1,
Hmm.
which one is supposing L1 here? Live
L1
linear,
Linear
is
is
linear and SAG with Saga.
SAGA. Saga is there, Saga
Mm.
is not there. So only a linear is there here.
Then
Live
it
linear
is
is there.
mentioned, sir, it is mentioned that data set is relatively small, so it will be
Correct.
linear. If
Yeah,
the data set
even
had been large, we could
no,
go ahead with Saga.
yeah, yeah. If we would have mentioned data set is large, no, then you should go with Saga. But if here we give you option
Newton.
Saga also, no, then you can select any one of them. Yeah,
So Newton's EG is not mentioned.
yeah. Newton series. I mean, some options are here. We have mentioned Newton series, no, but it is for L2, not for L1.
Okay, okay, okay. Hmm.
So that is it. Okay. So yeah, I think this is easy to plot. I mean, you can directly plot it. Okay, I mean,
Just
based
plot
on this,
or take the
yeah,
maximum.
Yes,
or I mean,
yes.
even if you don't plot, see 8, 9, it will lie somewhere between these 2 points, right? So see what are the neighbors? I mean, nearest neighbors. So first 1, 2. and yeah, the one of these two values. Okay, since already we know that three out of, I mean, two out of three belongs to class one, right? So obviously the prediction will be one only. Got my point? What, yeah, I'm trying to say here. I'm saying that this 8 comma line will 8 comma 9 will lie somewhere here, right? So the nearest two neighbors will be this one and this one. And one, I mean, we have to calculate from these 2 points. But yeah, since we know that the label of these two are same only, no, 1 comma 1,
Hmm.
right? So since already we understood that majority is one only. So if it's one of these two will be one and zero, no, then we need to calculate the distance from this point and this point. But since we have already seen, so that's why directly we can mark it.
Can you sir explain it again once? I
Okay.
didn't got it.
Uh, so see, the best approach would be to I mean, plot all the points. But what I am saying is that see, 8 comma 9, it will fall somewhere here. 2, 3,
Hmm.
5,
Yeah.
6, then 8, 9, 9 10. So I mean, two, if I have to say one closest point, so that would be difficult. I mean, maybe that also we can, and from the values we can see that this one will be the closest point. Two closest point, that is easy to know because these two are the closest point, no. Then for third point, no, we have to calculate the distance of this one from here. I mean, 8 comma 9 and 2 comma 3 and 8 comma 9 and 15 comma 6. But since we already see that the label of this one and this one is one only, okay, so already we know that 2 out of 3 is one. Okay, 3 out of 3 may be one, 3 out of 3 may not be one. But since we have already got that
Hmm.
majority is class one. So
Majority is
I mean,
one,
yeah,
so anyway we only take three
yeah,
out of these five, then
right,
anyway we are going to get one only.
correct. So if
Hmm.
these three are the neighbors, no, I mean, if the first 3 points are the neighbors, then also we will get one, and 2, 3, 4 are the neighbors, then also we will get one only. So that's why I mean the third point does not do. Yeah, third point doesn't matter in this case.
Hmm. Got it.
Yeah. Okay. So yeah, which of the following estimator can implement the partial fit method? I mean, any algorithm. I mean, behind which, I mean, if some iterative algorithm are working, no, then I mean, a partial fit method will work here. Then. Okay. So we know multinomial NB SGD regressor for these two things. I mean, yeah, this partial fit method will work. Okay. So yeah, kernel. So I mean, lasso is not a kernel. Okay. Then yeah, linear and RBF are the kernel. Scale is nothing.
Hmm.
Okay.
Scale is the pre-processing thing, right?
Right. Right.
Hmm.
Okay. Which of the following statements are true? Okay. So that I think, yeah, you can know that. Canon in Canon classifier, if your number of I mean, if you take a smaller number of neighbors, no, then the, I mean, you what you are doing is that your the boundary will be complex, right? Let's say I'm saying that based on two nearest neighbors, you are going to decide. So I mean the size will be very small. Okay. So that's why I mean think the, I mean, you will try to overfit it. Okay. Yeah, these are generic questions. I mean, you should revise them. Okay. Which of the
But its
following?
n is very
Question number,
small.
then in
Huh?
question number 18, all the regressors will do, right? Partial fit though they support, right?
Which one?
No, not
Okay,
all.
not all. Okay, SGD and multinomial NB.
Random forest is tree-based, right?
Uh,
So
It is
it
tree-based,
doesn't
no?
sorry,
allow
sorry.
iterative
Random
algorithm.
forest is tree based.
Logistic regressor
ML.
is functional based.
Mm-hmm.
SGD regressor is gradient descent based regressor.
Gradient descent wale will do. Yeah, thank you.
Hmm.
Okay, let's move to the question number 21. Which of the following options are correct regarding regularization? So, okay,
So in this
sim-
one, second one option, how it is, right? And
it
what does
okay,
it mean by bias then?
okay. Simply when you are ready, see, you know the regulation is simply means that you are reducing the variance, right? You are, I mean, you are try to avoid overfitting. Okay, it simply means
Basically, we
that,
try to reduce the weights that
haha,
given to a particular one
yeah.
for feature.
So just I hope you remember bias variance trade-off, no?
Ah,
Anytime
that
if you,
trade-off I
yeah,
remember.
yeah. So anytime if you are trying to reduce the variance, no, it
Hmm.
simply means that you are trying to increase the bias. I mean, you are moving to the increase the bias, right?
But sir, bias means favor. Means like it is giving favor to a particular thing, and the whole point of regularization is
See,
to reduce that favoring, right?
see, ultimately, whenever, I mean, yeah, whole point of, I mean, increasing the regulation simply means moving that, trying to, reduce the variance only. Okay. The main aim was to reduce the overfitting. So, but whenever you are just, see from this graph also, you see, whenever you will try to move in this side, no, ultimately what
Hmm.
you are doing, you are reducing the bias. You are increasing the bias, and you are, so there is a trade-off, right? And
That
I okay, and yeah, what your point you are saying, let's say from, if and it also completely depends from where you are moving. If you are moving from here, no, then
hmm.
simply means that you are, your bias is not, reducing. In this case, your bias is also, you are also reducing your bias also. Okay, in this case, if you are
Hmm.
moving from this point, okay, and if you are moving from, this point to here, then you are increasing the bias. So
So
I
how to understand from where we are moving?
yeah, yeah. So that, this question is not able to explain that part completely. Okay, because if you
Because
ask,
based on
yeah,
that, sir, first option seems little bit right to me.
it is a technique used to minimize the adjusted loss function.
It's not
And
loss function, but in regularization we add a penalty term to our loss function. So adjusted loss function seems right.
see, again, it is a technique used to minimize. So first of all, I think, yeah, this option is not completely true. Okay, it depends on
Ah,
scenario
that's
to
what my
scenario. So that is there, that is for sure. Okay, and second thing is that it is a technique used to minimize the adjusted loss function. Okay, and avoid underfitting. We do not try to avoid underfitting, no.
we
Okay,
try to
we
reduce
simply
overfitting. Ah, okay.
overfitting. Yeah, so
Hmm.
that is there. Yeah, again, you can say that, yeah, there are many if and buts. The question can be more clear. Okay, we have to include other points so that, directly we
Because I
land to
would
the.
not pick that.
Yeah, I understand. I understand. So see, what happens, whenever we are
Hmm.
creating these type of papers, we do not think much. Okay, whoever would have created it, no, because it's
Hmm.
ultimately just a mock. It's the aim is to just to give you the idea like what type of question you should expect. Okay,
Hmm. Hmm, hmm.
so that's why.
I thought that it's more about
Mm,
clearing of concepts. Also, for this
no,
question,
no.
sir, it should be 16. The 15 is written wrong in the option C.
Okay, if you have checked in, then that would be the correct thing. I don't know. I've been
Can we
checking.
read the question first
Yeah.
and
Okay.
then move to the options?
Okay. 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 Yeah. Yes. Correct. Correct. I think, yeah, we should do not go directly jump to the answer. Okay. So question says, we have to use counter vectorizer, and then based on the counter vectorizer, we have to give this. We have to talk about the shape. Okay. So okay. So the question is how count vectorizer works, right? So in what is the job of count vectorizer? Can someone summarize it? Then I'll say.
But in the last question, we have not discussed the elasticity kind of things.
Sorry. Yeah, elastic net. This one we know. No? Elastic net is nothing but the combination of L1 and L2 regression, right?
Sir, what are the means like parameters that is one parameter is there, no, that controls
Yeah,
this
L1
L1 to
ratio,
L2,
L1
L1
ratio
ratio.
equal to, yeah. So that is by default it is 0.5. So that you give equal weightage to both, and yeah, just by increasing or decreasing you can give the weightage. Okay. So
Always
yeah,
our
that is.
penalty should be elastic net.
Haha.
Hmm.
Okay. Yeah. Let's move to this question. Okay. How count vectorizer works? See, count vectorizer is just a feature extraction tool. So it simply converts your text document into matrix of text token. Okay. Where
Unique.
in easy word, yeah, in easy word, it simply it simply creates a matrix where it keeps the count of each number. Okay, it's a count of each term.
Hmm.
Okay. So why you do it? Because machine do not understand text. Okay, so that's why you just try to convert it to some numbers. Okay, so yeah, so basically you what you do is that you split each document into individual words or tokens. Okay, and then yeah, based on that, you just save the frequency of that word. Okay, so yeah, that is there, and yeah, like that you can do it. Okay, for example, here in this one, just count the number of unique words. Okay, unique words. Okay, and there are multiple terms like you want to use the stop word equal to true and stop word equal to false. Okay, so that is there.
Unique
Uh, Sorry.
unique word counts are actually 16 in this, not 15. So that's
Yes,
why I was getting confused with that options that are provided.
So just run it.
C should be 16.
Okay. Have you run this code? What is the answer there? It is giving 15 or 16. So most probably there would be somewhere some space will be there, and it would have counted that. Okay, that is possible.
Okay.
Or maybe yeah, that, or maybe yeah, this dot,
Uh,
not the dot. I mean,
no,
after it's
Then
yeah.
also it should increase now.
even
Yeah.
if I take that first line, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 10 words are there.
Yes.
Only the word there is repeating twice, so which means nine. Uh,
Okay.
Nine unique words are there. Then in the
Uh-huh.
second line, difference between train, test, called, variance. These six,
And
seven. These seven are actually a unique one.
Yeah. Okay. Okay. See, whatever the concept, you understand the concept, no? Just
Correct.
try it.
Mm.
Okay. And yeah, if this is not giving the answer, so most probably the issue would be
Nearest
okay.
one mark.
Yeah. 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 I mean, no. So obviously they would have given the wrong options. Okay, that is
Sir,
possible.
what
But
I
yeah.
did in this was
Hmm.
that I know that the shape will be row times column. So I didn't, means like first I didn't check it. Later when I tried it, I got that it will be 16. But there are two rows. So that means the first value should be 2. And obviously these will have lot of unique values. It will not be 3 or 2 or 3. So that's why C will be the answer.
So unique
It has
values are
exactly
15 only, right?
Yeah, it's 16.
No,
it's
15.
16,
Yeah.
it's not 15.
No, it is 15.
Oh,
Sir, actually, up to my knowledge, there is another operation to be conducted
There is. Sorry.
before going for this one, sir. So, if you see the train and training, the cutting will be there. Means last ing or ly or kind of things will be cut it off first of all in that particular operation. Then we will be
Hmm.
getting limited number of tokens, like actually means actual, and
Hmm.
training will comes to only train. So train will be double time it will be there. So it will contribute. I mean, considered as one kind of thing. I mean that is not mentioned in this
there's,
one question.
yeah,
it is not
so that what
mentioned,
you
I
are talking
thought.
about is limitarization. That is not mentioned here.
Okay. I was not able to hear properly what you guys are saying. So I mean, okay, just to go one by one. So first person is saying that I mean, is there something missing in this code or what?
No, sir,
In the question,
nothing.
something is missing, sir. Means I forgot the name of that particular operation, wherein the extra terms. If you see the word like actually,
Huh?
it will be last ly will be cut off. The
Okay, so
token will
that
be
is
actual.
yeah,
In the same
yeah.
case, where when it comes to training, it will be cut off the ing form of that one. It will take train as one
Okay,
token.
okay. You are see there are two things you are talking. First is lemmatization. So where I think you just take the root word, and second thing is you are asking about you are talking about using stop word. I mean removing the stop words. Okay. So see,
Hmm.
yeah, those things are there. If we use those things, then yeah, definitely it won't count like is the like terms like this. Okay, and yeah, apart from this, I think you were talking about elimination where you just try to get that root word. Okay, I mean the different variation, no. So you won't count that as a different word.
Yeah.
Okay, yeah. So yeah, I mean in real world, I mean whenever you are handling this NLP things, no. Okay, there you use those things. Okay, but yeah, here just it is just I mean we just try to check whether you understand how count factorizer works or not.
ఇదంతా
Okay.
తినకుండా ఉంటే ఉంటుందా నీకు ఇదంతా మంటెత్తాయి ఉంటాయి.
So we'll move ahead, sir.
Ha
Sir,
ha. Yeah.
sir, just one thing. Like
Yes.
there are people who are saying right. There are 16 unique words. So the answer actually should have been 2 comma 16.
Yeah, yeah. Answer then the 2,16 should be there. Okay,
Yes.
I'm just count it. Okay, I mean just check it. Okay. So there is a possibility that I mean maybe some words you might have I mean missed or I think bias is there. Okay, let me also count. Bias is actually 3, 4, 5, 6, 9 term is there. I think only the is repeating here. The is
Hmm, yeah.
almost 3 times. Okay, I mean here 2 times, and here also like we have the. Okay, so yeah, yeah, okay, maybe okay here 9, 10, 11, 12. Okay, at 13 and is there.
Test is 14.
Test is 14.
Error
Error
and
was also
error is
error was
not there.
okay,
A
and
call
then
is 15. Variance is 16.
variance is 16, right? So total 16 terms are there, right? Okay, or I mean just take it. No, I mean okay. I think and someone is saying that train and training should be same. So okay, I mean, okay, then in this case, no, I got the point. I think someone was saying the train and training. No, in that case, no, just see the what are the default values. Okay, whether I mean, whether they are using these things or not. Okay, I mean, in the what is the default values. Okay, for example, lowercase issue is not there in this case.
No.
Yeah,
So
and then
default, it doesn't apply lemmatization directly.
okay. Okay, if it does not applies, no, I mean, yeah, then yeah, 16 values will be there. But since they have mentioned it, no, so I'm highly convinced that there would be 15 values. Okay, I mean, but yeah, just cross check it. Okay, otherwise, I also, I mean, just I'll
The
cross check
code,
it. Okay, uh-huh.
but I ran the code.
Okay, so it was giving 16 only, right?
It should give
Uh,
16 only because that
uh-huh.
are the
If
numbers
there are
we need.
16 values, no, then it will give you 16 only. Okay, and if it is not
No
giving
problem.
16, then yeah.
Move ahead, sir. Means like,
Yeah.
can we move ahead?
Okay, ultimately, if you understand the concept, that yeah, things will work using those concepts only. Okay. So in this question, so they have given you two decision tree classifier. Okay, the given the configuration of tree one, which decision tree is more likely to overfit. So I mean, see, more overfit means, I mean, simply whenever you when you do not put any max depth criteria, no, then in that case, I mean, your tree will overfit. I mean, the decision tree will overfit on your data set, training data, right? So in this one,
Sir,
max.
sorry, my internet connection had gone. So in the previous question, what did you conclude? It is 216.
So that you just check it. Okay, otherwise, I mean, if you understand the concept, that is fine. Okay, I mean, just cross check the thing using the after running the code. I think someone said that yeah, after running, even after running, they
1516
were
is
getting
okay, but this two we are getting because there are two values, right?
uh
There are two sentences that therefore we are getting two.
yeah, right. That too is for two samples. Yeah, I mean, yeah, two sentences or two document you can say. Yeah. Okay, so that is there. So in this one, I mean, the in case A, no, tree one, max depth is none. So I mean, you are not limiting the depth. Depth is the depth gets limited by this minimum sample split. Okay, so yeah. So in this question, so I mean, I mean, you are limiting your tree. I mean, up to depth three only. So I mean, you will go up to level three. So that's why I think yeah, this is I mean, this one you may face the case of you may face the issue of overfitting. Okay, in tree one.
Overfitting.
Right.
So overfitting is only because of max depth parameter.
See, I mean, it can see. I mean, ultimately, no, the depth you can limit using minimum sample split also. Here we are saying that minimum sample split should be 20. So after, I mean, if the minimum sample is less than 20, no, then you won't split. So like from this also you can limit your tree depth. Okay, or minimum sample leaf also. Through this also you can limit your tree depth. Right. So
Okay.
yeah. So all three terms are, I mean, important.
So again, a
So
lower sample split or lower min sample sleeve is leading to overfitting.
see, okay, just say again what you were saying. So in this case, no, out of these two,
Was
okay, for sure.
verifying what you said. So a lower min sample split and a lower min sample sleeve will lead to overfitting. Because
Minimum
as you
sample,
said, yes.
correct. Because see, minimum sample split is simply means that I mean at least this number of sample is required to split further. Okay, if I'm mentioning minimum sample split as like a two, three, no, so at least up to even after this sample split also like it will I mean after even after getting this many samples, it will try to split. Okay, if some other criteria stop the splitting, no, then only it will stop. Otherwise, it will try to split after even after that. Okay, so yeah, that is there. So question number 24, this simply says which of the following statements are correct. So we are using bagging classifier and the base estimator is Cannon classifier. Okay. The back CLF will throw an error as it only accepts dysentery. So that is not true. Each base Cannon classifier will be trained on the entire data set. Okay, is it true? Then the option says maximum sample equal to zero point 0.5 parameters means each base estimator in the sample is trained on 50% of the training sample. So which is true? I mean, because we have already mentioned max sample equal to zero point 0.5. So for each, I mean, for each Cannon classifier, you will take only 50% sample. Okay. The ensemble will use sequential computation due to an n jobs equal to -1. N job simply means that I mean how many
Parallel
you want
computation.
to run parallelly. Okay, and -1 it means simply means it will use your all resources. Okay, I mean, so how many
Hmm.
max parallel jobs are possible? It will try to those many number of parallel jobs. Okay, so that is there. So yeah,
Correct.
option C is only correct. Okay, so let's move to, you are using a random forest classifier from sklearn for a multi-class classification problem. You want to ensure diversity among the trees to avoid overfitting and increase robustness. Which combination of parameter setting will contribute most to achieving the objective? Okay, so
Sir,
yeah,
in
huh.
this question, what does diversity and robustness mean?
Diversity and robustness simply means that more generalization. Okay, more
So it is
generalization model.
combined term. Means like we have to think it about
Aha.
combined, not separate.
See, I mean, we are using all the words so that, I mean, the questions are more make questions are more clear, and every terms are focusing on the same thing. I mean, redirecting you to the thing in the same direction. Okay, I mean, to in the single direction. Okay.
So it means reducing overfitting. That's all right.
Haha. I mean, ultimately, yeah, the same thing. Okay, you want to ensure diversity among the trees. Okay, and among the tree, see here, you want ensure diversity among the trees means, I mean, different samples for the different trees. Okay, I mean, it should not be that two trees should not be very similar. Okay, so it
Okay.
simply means that, yeah, I mean, so here, no, I mean, if you are giving the same sample to two trees, no, so both trees will be very similar. Okay, I mean, or both tree will, I mean, since the same, almost similar data, so I mean, almost similar output, both tree will give, no. So I mean, there
Yes.
won't be, yeah, redundancy will be there, no. So that is there.
Hmm. Okay.
Yeah. So setting n estimator to 10, max depth to 3, and using criteria equal to entropy. So see, we are already setting the, I mean, these terms won't help you to, I mean, see, max you are setting number of estimators to 12. Okay. So how many number of estimators you are going to use? Only 10 estimators, right? So I
Only
mean,
10.
it doesn't much make sense. Okay. Let's say if we read the second option, increase the value of n estimators, setting maximum features to a value less than total number of features. Okay, and setting bootstrap to false. Let me read it again. So this is saying increasing the value of number of estimators. Okay, okay, so that is good.
That's good, sir.
Setting,
And we are
setting,
basically generalizing it better, right?
huh.
Okay.
No,
Maybe I
sir.
also, maybe I
Bootstrap is
also need
false.
to read it. Yeah, maybe I also need to read it properly. Okay, just let me also understand the point. So setting max features to a value less than the total number of features. Okay, if you are saying no, I mean, let's say here in this case, no, diversity won't be there much. Okay, because for, I mean, you are setting max features, okay, to a value less than total number of features. I mean, and setting bootstrap equal to false. So, I mean, yeah, almost one tree is will be able to cover a maximum number of features. Okay, in this case,
Okay.
yeah. So I mean, maybe 80 or 90%. Okay, since they are not exactly mentioning the exact number, or I mean, maybe something concrete value. So in this case, no, what is going to happen? No, there is a very high chance that, let's say, maybe I should use increasing the value of numbers, setting max features to a value less than the total number of features. Let's say you have total features as a 20. Okay, let's say 20 features are there, and you are setting the max features to a value less than total number of features. Maybe it's something 18 to 10 or something like that. If that number is high, no, if this number is high, there is a very high possibility that two trees, there won't be much diversity between two trees, right? Getting,
Yes.
yeah. So that is there. So that's why this option might not be very true, or I mean, it's not the, or I mean, we need to check other options. Okay, and then we have to decide the most appropriate one. Okay,
One question.
yeah,
Bootstrap to false. So that means that means like the samples that will be taken will not be random, right? It's like some percentage of samples will be repeated.
correct. A bootstrap equal to false. Can someone say what does it mean? Okay, or may just clarify it, and then I'll tell. See, bootstrap simply means that, I mean resampling, or I mean the things what you took, no, that would, I mean, again you are going to take that, or you are not going to take that. That parameters you decide based on that. I mean that you decide
If it
based
is
on setting
false.
this boot. Huh. That you decide
So
based
if
on
it is
setting the
false, then
bootstrap equal to false or true. Okay. If bootstrap equal to true, then resampling is done. I mean, whatever you take, no. So again, for again, when you are taking, I mean, let's say you have 1,000 samples, okay, or 1,000
Mhm.
samples, 1,000 or 100 estimators. Okay, let's say
Mhm.
you took, I mean, first 10 columns, or first 5 estimator, and some samples for training first
Hmm.
model. Okay, or first tree. then again if you bootstrap is true, no, then again you can take those, right?
Okay.
Yeah. So
So it is
yeah, if
actually a good thing for this
yeah,
particular one.
bootstrap
If
equal to
that
true.
setting max feature is not there.
Sorry.
If setting max feature part is not there in our second option, so bootstrap
Then
setting
yeah,
to false
bootstrap.
is a good
Yeah.
thing.
Hmm. See again, yeah, that is true. So here, what happens? You know, bootstrap equal to true. No, so but when your bootstrap is true, no, then there is a high possibility that there may be some redundancy. Okay, I mean there can be few, and if the max feature is too low and bootstrap is true, then there is a, I mean there is a possibility that there can be redundancy. Okay, I mean the two trees, I mean two distant tree giving similar result. Okay, so that
Oh,
is
it's like
possible. Yeah. Hmm.
sir, when bootstrap is false, as you have said just right now, that we will not take those values which are already taken by some another tree.
Correct. If bootstrap is false.
Then how redundancy will be there if we
Yeah.
set that bootstrap is equal to
No,
false?
I was saying that if bootstrap equal to true, and then
Okay, okay,
this, yeah,
okay,
this
okay.
one is there. Okay. So yeah. Okay. Option C says setting n estimator to a high value, number of estimator to high value using criteria and getting max sample to a value less than the total number of samples. Okay. So in this case, we are not upping. I mean, by default, bootstrap is true only. Okay. So what is happening is that you are setting number of estimators to high value. Okay. So yeah, you are not limiting your tree to work only. I mean, using this many estimators only. They can take any number of estimators, and then setting a maximum samples to a value less than the total number. So obviously, the maximum samples would be less than the total samples only, right? So okay. So then what will happen? No, simply I mean in this case what will happen is that, see, it's simply, I mean here randomness will be higher, right? Because you are setting I mean you are setting an estimator to a high value and max sample to a value less than total number of samples. So there is a very, I mean randomness will be high because of the max sample. And also since the number of trees are higher, no, I mean number of trees are also higher here in this case because you have set number of estimators to a high value, no, then it simply means that, yeah, number of, you have increased the number of trees. Okay, so it will simply increase the diversity and robustness, right? Because of these
Okay.
things, no, I mean yeah, diversity will be higher. Okay.
So it has nothing to do with Guinea, that
uh,
criterion.
Guinea criteria, basically Guinea criteria is faster. Okay, I mean if you are,
Okay.
instead of entropy, you know,
It
it takes a
compares
yeah,
the errors between the leaves,
yeah,
right?
right. So entropy takes a higher time to train. Okay, so that is there. Yes. So, I mean again, if I say
If in place of Guinea, if any other is there like entropy or log loss, it would then also this option would be a fine option.
yeah, I mean other things are making more sense. I mean you have to select out of these four only, no, out of these four,
Hmm.
out of these four, no, this option is making more sense here. Okay, I mean, and again, see, there still, if you ask me to point out, I mean things which are missing here, no, we don't know how many total number of samples are there, or how many total number of estimators are there. Here we are saying setting number of estimator to 10. We don't know, I mean whether the, I mean total 12 estimators are only there or what, right? So that is there, but yeah, max depth is 3, no. So this is this thing is kind of limiting the, I mean us to select option A. Okay, so it simply, I mean it overly restricts you, or I mean it overly restricts the capacity of trees. Okay, so that's why, I mean due to this, no, due to this part of this option, I mean this will underfit, right? And there won't be much diversity. Okay, so in option B, if you say, see, simply if you are a bootstrap equal to false. Okay, I mean, in each option, no, there is something. Okay, I mean, which is helping you to decide whether this is appropriate or not. Okay, in this one, bootstrap equal to false. So it simply means that, I mean, see, since bootstrap is equal to false, no. So then, what I can say is that, so in the sampling process, no, there won't be much diversity, right? And apart from this, no, when you are increasing the number of estimators, okay, and it simply it helps you to diversify. Okay, but robustness thing, you know, I mean you are controlling it because, I mean the thing, because of this term. Okay, So if you ask me, no, I mean, again, if I start pointing out, like, I mean, about things like, okay, which, I mean, because of which you have to just reach at this answer, no? Okay, then we have to improve all the options. Okay, I mean, there should be something, okay, specific mentioned in each option, so that then I think, yeah, it will make more sense. Otherwise, I mean, but yeah, still, if I ask you to select, I mean, you have to select one of these four, no? Then this
So
option
what
makes more.
about D?
Uh, Setting max depth to none, minimum sample split to 2, okay, and minimum sample split to 1. So it simply means it is nothing but the case of overfitting, right? Yeah.
Good
Yes.
over.
And we in questions only we have talked to avoid overfitting,
So
right?
we are already saying ki diversity and robustness, so more generalization. So therefore,
Mhm.
overfitting is not an option. Okay.
Right. So yeah. In these questions, no, ideally, if you ask me personally, then I would suggest no. I mean, the option we should make these questions. I mean, these things more clear, or I mean, there should be more information given. Okay, the context and everything. Okay, otherwise, I mean, yeah, people can. I mean, definitely you can argue on these questions, but yeah, since you will be in exam, and at that time you have to mark one of these four options, then at least, yeah, you have to go with the a more appropriate option. Okay, and more, yeah, which option, the option which makes more sense. Yeah, that is there. Okay, question number 26 is, you are using a decision tree classifier from sklearn.tree to build a classification model. Which of the following statements is most accurate regarding the parameters and attributes? I think, yeah, that you can directly read, no? Max depth parameter ensures that tree is prone to have a maximum depth, while the tree dot max depth attribute retrieves the depth of the actual tree. I think, yeah, this we already talked.
This was covered in one of the session, if I
Mm.
Okay. Yeah. Question number 27. I think we know that how to. Okay, let me read it. You are aiming to optimize an AWS classifier that uses a decision tree
We did
classifier.
this question yesterday.
So we have
Yeah, yeah.
done
So that's why
we
I
did
also.
it. Sir, I have just
Uh,
one question
house
in this one.
three.
The D
uh,
option. Here, best estimator underscore underscore max depth. It is because of AdaBoost how we implement it, or is it is because of the grid search CV that how we are implementing that param grid?
whenever you are in grid search, no, I mean, if you are, I mean, if you have to mention the hyperparameter, which is the which belongs to their base estimator, no, then like this only you, I mean, denote for base estimator, right?
Even though it
That's
is
why,
not a pipeline.
in grid search, like this only you denote it.
I think, sir, in
Okay, I
one of
mean, maybe.
the previous things, like similar question when we saw, instead of base estimator, we had done estimator underscore underscore max depth, and like, then also option D was only correct.
Okay, I
Yes.
mean, instead of base estimator, we have used only estimator, right?
Estimator.
Hmm.
Yeah, yeah. So it completely depends how sklearn has, I mean, uh, how sklearn has configured these things. Okay,
Okay.
if it is working, yeah, then yeah, I
Maybe
mean, you can
different
use that.
projects, it had
Oh.
different, so in that way.
Mhm. Yeah,
Sir, what
and
is the
then
answer?
I
27.
think, yeah, D no. I mean, base estimator
D.
underscore max depth. Okay,
So
like
we are
this, you denote the max. I mean,
setting these values for ADA boost, and inside of that, the estimator we have to set these values. So therefore, we have
Yes.
to do it like this.
okay,
Sir, why D? Sorry.
okay. See, okay, why A and B and C? Okay, let's say talk about why not A and B and C. Okay,
Okay.
here, yeah, in A, no, we are just okay. I mean, basically, what the question is asking that you have to set few parameters for, I mean, base estimator, which is decision tree classifier, and you have to set few parameters for ADA boost. Okay, here you are setting the parameter for ADA boost, okay, but not for decision tree, right? In this ones, you have not mentioned anything. Okay, so by default, it will try to find these hyperparameters in ADA boost only. Okay, so I mean,
Uh,
this is the way how you define the parameter values. Okay, how you define the base parameter hyperparameter values, and yeah, like this, you know, I mean, you define the uh, I mean, normal your estimator hyperparameter values. Okay, that's how you define it. Okay,
Okay.
yeah. Question number 28. You are working on a data set containing customer purchase data. You want to segment the customer into distinct groups based on their purchasing behavior. I mean, this term itself says that you have to group the things. So all the things are, I think, prediction based models. Okay, I mean, only k-means clustering is there, which do this
Yeah.
grouping thing. Yeah. So yeah, that is there. Okay. Yeah. Let's see the question.
Sir,
Next
this
question.
one can you explain
Okay,
ward,
you are let
ward and
let
average.
me read let me read it first. You are working with a data set of geographical locations and want to group similar locations together based on their distances. The data set includes latitude and longitude coordinates for each location. Which linkage method would be most appropriate for this scenario? Okay. In this case, I mean, single linkage simply takes the minimum minimum distances
Hmm.
Yes.
between two points.
Yes.
Okay. Yeah. Okay. So let's say if the 2 3 points are here, okay, and there are 2 3 points here. So yeah, single linkage simply means the smallest distance, right? And complete linkage means the maximum distance,
Yes.
right?
Okay. Makes
Okay.
sense. Huh?
So here if you see no single point, no, I mean if we uh let me also think it in different ways. Okay.
It
So
should be
what would
single
happen?
linkage according.
Yeah. So what would happen in this case is that there must be things like this one. What you say is this one, latitude and longitude is there. Let's say there
Hmm.
can be 2 points like which is okay. I mean in latitude, no. Let's say there are points like this. Okay. So and there are points like this. Okay. Maybe so there is I mean if we just take that latitude and longitude, okay, based on that only you are going to decide the location.
Hmm.
Mm, and there must be things like I mean the irregularities will be definitely there. Mm, uh, what should we say in this case? Single linkage, and I am not able to think about anything specific which I mean will I mean promote any particular option. Okay, because in single linkage, I mean we are using minimum distance. In complete linkage is maximum distance.
So one thing that I would like to know is like if we, as per what I know, the clustering is basically to group the data and grouping in the closeness sense, right? They are very close. They are representing similar kind of behavior. So that means they can be closely grouped. And if they are closely grouped, then their cluster distance, two different clusters will have maximum distance. So in that sense, it seems right. But if we see the internal distance between the points within a cluster, then this single linkage should be the answer.
See, we don't have to see an internal link. Here we have to check the distance between two clusters. No, you have to basically, I mean, you have to check the distance between two clusters. Okay, based on that only, like you need it. No, I mean, based on that you have to cluster it. Okay,
Hmm.
so which one? If even if I'm thinking no, currently I'm also not able to think. I mean, why one particular options will be correct?
Sir,
Why?
ward linkage, how it works, and average linkage also. Average, I understand. Ward, how it works.
What I think, just check it. Okay. I mean, there is a formula. No, I mean, in the last session only, like we were discussing.
We were discussing
Yeah.
this.
Okay. So, but let's think about this one. Okay. Maybe I'm not able to think about any specific point. Okay. I mean, which makes option A is correct. Option A is as more appropriate or option C is as more appropriate. I'm not able to think as of now. Okay. Uh, because see, ultimately, if you go with the maximum distance, no, there is a chance. I mean, go with this complete linkage. I mean, since there is a high possibility that irregularity are there. Irregularity will be there in the shape.
Hmm.
Okay. So I mean,
But how can we kind of decide here? Like single linkage is just
hmm
minimum of minimum distance from clusters.
hmm yeah,
Complete linkage is min of max distance between clusters. Like
correct,
it
correct.
could be anything, right?
Yeah, that's why even I'm also not able to think any point which will make option A as correct. Option A as more appropriate or option C as more appropriate. I also need to see. I'm not
What
able.
about
Currently, I'm not able
latitude
to.
and longitude?
Yeah, so I mean still see latitude and longitudes are there. Okay, but you have to cluster it. Okay, I mean you have to form the
Yeah.
group. For example, let's say a different continent, Asia, Africa, Europe, and all. Okay, I mean like this only. Let's say you have, I mean using the any of these linkage formula. Okay, and you have categorized it. So which one is more appropriate here? not able to think as of.
Same, sir.
Same.
Like if
Uh,
we get the same question, we'll just obviously memorize this and
hmm.
mark. But
No, no, at least I
we
won't be
could-
asking this question because even I am not able to think. Okay, currently I am not able to think. I mean, which option will be more appropriate here? Okay, I mean, what would be the logic here? I am also not able to think as of now. Okay, single linkage is there, complete linkage is there. Okay, maybe I'll take some time, or I mean, if I'm able to think about any point, no, I mean any specific point, or you guys, if you guys have some suggestions, then just tell me. Okay, otherwise I'm not able to think about any specific point. Okay, or any specific logic, which will, I mean, help me to decide whether option A is correct or option C is correct.
Okay.
okay, sir.
Hmm.
Because I'm able to think about, I mean, but yeah, so there, I mean, see, if it is these points are about latitude and longitude, no, then yeah, some due to, I mean, due to different shapes, due to different shapes, I mean, due to irregularity and there's the rivers and all. So, but I think that won't make much. I mean, still, I'm not able to think. Okay, let's ignore this question for now. I mean,
Okay.
yeah. Okay. Uh, let's move to the question number 30. So, question number 30 is here.
Sir,
You are, huh,
one interpretation for the last question.
huh, huh.
Sir, when we have latitude and longitude, how do we calculate the distance? Is it the
Um,
same way when we calculate normal Euclidean distance?
so yeah, I mean, let's say you have a point. Okay, I mean, you have point this latitude and longitude is there, and then you have a point like this. From here also you have latitude and longitude. If you want to calculate the distance, I mean, maybe directly by subtracting those points, no, you will be able to calculate the distance. Okay, I mean, if you want to, and maybe if you want to calculate Euclidean distance, or you just want into absolute terms. Okay, so here, no, here basically, if you have 2 points, okay, let's say, I mean, you can calculate using that also. Okay, or otherwise, I mean, even using Euclidean distance, you will be able to get this distance. Okay, I mean, whatever format you choose, no, that what will happen in that case is that if you, let's say, let me see, think about it directly. Let's say if one point is here and one point is here. Okay, and if you are calculating the Euclidean distance, so it will give you this. But yeah, there is a possibility that you want this one, right? This one, I mean, because due to, I mean, irregularity in the shape. So ideally, I mean, Euclidean distance will give you this one.
Sir, actually Euclidean distance, what I searched is for linear
Correct, correct.
approximation.
I'm getting money. So I'm saying no. I mean, let's say, oh, okay, I'm
But
just
whenever latitudes and longitudes are uh, made available, that is talking about the areas. It
right, right, right. I'm getting your point. Like what you are
circles
trying to
is
say here
so
is
the
that
distance is different.
okay. I mean, maybe if let's say this is the Earth. Okay, I mean, this is not very good. Let's say one point is somewhere here and another point is somewhere here. Okay, I mean, in the at some other angle. No, if I'm just getting this Euclidean distance, no, that is direct distance like this. Okay, this is the minimum distance between these 2 points. But if I'm talking about, I mean, Euclidean distance is nothing but this minimum distance between, or a minimum distance between these 2 points. Okay, but ideally, I mean, since this is the Earth, no, ideally it is it should be something like this, right?
Hmm.
So that point I'm getting, and yeah, if I think about this point, so then it makes more sense that, I mean, yeah, I mean, it is a possible that if one point is, I mean, somewhere here. Okay, and there is no, I mean, due to this shape, no, these 2 points may be, I mean, in Euclidean distance can be same. Okay, from, let's say, from A to B and A to C, the Euclidean distance can be same, but yeah,
Maybe this is the reason why the complete linkage is
yeah,
because
something. I mean, yeah, I mean, this
they are
point is,
giving the minimum of maximum distance, right?
hmm,
So
so
maybe
Hmm.
this,
that's why.
yeah. So
So we
here,
take the
yeah,
maximum, which are
correct,
going
correct,
to be any the globe distances, and then out of those we are taking the minimum.
correct, correct. I mean, I'm also reaching to that point only from this example. I mean, I mean, just said, if instead of going to the minimum distance, no. So there, okay. I mean, first of all, I mean, we don't have to think about Euclidean distance here. So another thing, the main thing is that no, here the distances are like single linkage and complete linkage. Single linkage, no, what happens is that it will think that, yeah, these two, I mean, there is one group here, there is one group here. It will take that, I mean, it will think that these, I mean, both, or I mean, even though the smallest distance is same from this group and this group, but still this group is highly, I mean, highly, or maybe, I mean, I should say it, I mean, this is very not similar to this group A and B, C, because here you have to see the, I mean, because of irregularities and other things or geographical constraints. So, you, I mean, these 2 points may look that, I mean, these 2 points are equidistant from here, but ideally, I mean, in real world or in our Earth, that too would not be the case. So yeah, this is one point which, I mean, I'm not able to I mean, say it in a better manner.
Sir, can I try a bit over here, sir?
हाँ हाँ बिल्कुल
Ah,
yeah.
yes, sir. If you take the, if you have consider the first drawing what you have done, sir, and if you put A, B, C to that one, names and all like that, A, B, C.
Okay,
Yes, sir.
I mean,
In this case, actually, even though AB is a straight line, it is on the earth kind of thing. But when it comes to aeroplane or the ship kind of thing, the transport will be done in the number two, what you have written, that
right,
route
right,
kind of thing.
right.
Because of air gust and the permissions, what you have mentioned just now. The surface of some of the countries is not allowed to fly and all like that, or risky countries to another country kind of thing. Because of that one, even though the distance is lower, they will not offer. I mean, go for opt for that particular route. Number one route, or they'll always go for a number two route because they can save some petrol or the fuel kind of thing. The second one is the permissions. These are the two aspects wherein all the aeroplane movements will be in the circular or the in the half circle mode only, not point to point straight lines kind of thing. That's what I have seen that one as a video recently, sir.
Yeah, I think the same thing. I mean, maybe we should, I mean, come up with a better word, or I mean, the crisp words. But yeah, I think this logic is making more sense here in our question. Is that because there is a possibility that these 2 points, I mean, the closest distance would be, I mean, this one, root one. But ideally, I mean, these 2 points are lying. Let's say this is Earth. This is, let's say, this is the center of Earth, and this is completely spherical shape. Okay, compare, yeah, this is a spherical shape, and point A and point B is nothing but the 2 points of diameter. Okay, I mean, okay, so that is there. Okay, but yeah, the ideally you cannot go from one to B, A to B. So that's why, I mean, these 2 points, I mean, if the one point is somewhere here, okay, at some this place, no, okay, and some point would be somewhere here in that point, okay, on this direction. So yeah, based on this distance, no, I mean, this shortest distance we should not decide. Okay, based on the maximum distance we should decide here. So yeah, using this logic, I mean, I mean, complete linkage option makes more sense. Okay, I think yeah, this
Let's
logic,
move to,
yeah,
like, this logic is okay. Maybe we can.
yeah, this logic satisfies our, I mean, the option A as a correct option. But yeah, I'm not also not able to come up with the better, I mean, the more cleaner version of the words. But it is something like I'm just able to feel it, I mean, I'm just to understand things. Okay, I'm just trying to implement this logic. uh, because, I mean, yeah, there is something related to, I mean, this distance, I mean, due to the obstruction, okay, which you will face in the direct action. Okay, I mean, the single linkage, I mean, there, in single linkage, you may, I mean, just because of this shape, irregular shape of Earth, or I mean, the spherical shape of Earth, there is a possibility that, I mean, single linkage will not, yeah, okay, maybe I should say it like that. Due to the spherical shape of Earth, single linkage may not be the appropriate one, because always the smaller distance is not the best thing. I mean, okay, you cannot decide the differences
Cannot
just
drive
because
to
of,
the,
yeah,
we
just
cannot
because
drive
of,
to the core of the earth and then travel to US if we want to.
correct. So yeah, that is there. Okay, let's move to the next question. Question number 30 says, you are analyzing a data set customer transaction history each transaction includes the purchase amount and timestamp. You want to identify group of customers based on their spending behavior. Which cluster approach would be most appropriate for this scenario? So okay, so there are two approaches. Okay, density based clustering and distribution based clustering. Distribution based clustering simply makes more sense when you see, no, I mean there is I mean some particular, I mean your data is following some particular distribution. Okay, so in that case, no, distribution a centroid based approach, or I mean, yeah, centroid based approach or distribution based approach makes more sense. Okay, but in case if you find, no, I mean there is some irregularity in your shape. Okay, irregularity in your shape, no, in that case density based clustering will be more appropriate. Okay, and yeah, there is a difference between density based clustering and I mean and distribution based clustering, is that in density based clustering, no need to define the your number of clusters. Okay, basically it sees the density. Okay, and based on the densities it decides the number of clusters. Okay, and yeah, and the density based clustering is less susceptible to beginning positions. Okay, uh, and let's say if you have, no, I mean in distribution based clustering, it always try to make I mean similar I mean cluster of similar shapes. Okay, because I mean it's completely based on the distances, no, so it is like that. But here, no, here I mean in this density based, it is very good when you have a different shape of, I mean because it is completely based on density, no. If even if you're, let's say, I mean say, okay, I mean there is, I mean irregular shape and even some overlapping is there, no, in that case also, no, density based clustering will make sense. Okay, I mean in those cases, no, density based clustering like db scan works more, or I mean is more helpful. Okay, so that is there. Having said that, let's see the question like which it asks. Okay, you are living a data set of customer transaction history. Each transaction includes the purchase amount, okay, and timestamp. Okay, so you want to identify a group of customers based on their spending behavior. So here we don't see that. I mean, we don't from this these two things. I mean, purchase. This is nothing but the amount, and this is the timestamp. So I mean, from here, at least what we can understand that I mean, so there would be some I mean some pattern in the timestamp, no, since it's a kind of what you say, I mean 24-hour
Sir,
cycle based
purchase
type.
amount might be related
Uh-huh.
to timestamps. Purchase
Yeah,
amount might be related to timestamps. If we have a timestamp saying that it
right,
is
right.
some festival, then purchase amount
Uh-huh.
will be higher, else it will be low.
Right. So that is there. So I mean, this is what we have to decide. No, I mean, this is what we have to predict. Or I mean, that's how. I mean, this clustering algorithm will do. Okay, I mean, that's how. I mean, that's how you will group, right? So okay, okay, you are talking about this density. Okay. You are talking about this density. I mean, at some particular at fetch time, so this density would be higher, right?
Hmm.
Something like this. Yeah, so again, yeah, this also makes sense. I mean okay, from this question it seems like how you want to approach this question. If you think like in that action, no, then yeah, density based clustering will be the better option. Okay, I mean if you see the, I mean if you take the timestamp, I mean time part as a more if you give the more importance to this part. Okay, in that case, no, if you use density based clustering, no, that will be more helpful. Okay, because I think, yeah, as you were saying, no, the density will be very high at these points, like during the festivals. Okay, then I mean in those cases, no, I mean it will if you use or I should say that if you use density based clustering, no, it will group like this. Okay, I mean here you will or maybe in second thing I can say is that if your focus is more on the purchased amount, no, okay, or I
Distribution
mean
based.
yeah, then the distribution is the better. But other, if your focus is more on the, I mean
Uh,
timestamp part, no, then density based clustering will be the better option. Okay, because yeah,
So, what is the
here
base logic for distribution
uh,
based clustering and density based clustering?
see in density based clustering, as as I told you, I mean in general, if you have to do, I mean in real life, if you get the data set, no, if you think that, I mean so I mean the shape would be irregular. Okay, I mean the shape
Hmm.
of the samples would be regular, and also apart from this, I think you see that some overlapping is possible, no, in that
Hmm.
case. And as the term said, density can be different, no, in that
Hmm.
case, no, in that case density based clustering algorithms are better. What happens, no, let's take one example. Okay, let's say here you have few samples like this. and this is the limitations of k-means also. Okay, here the and so many points are there, and there are few
Hmm.
points like this here. Okay, and yeah, I mean maybe I should. It is not very. I mean it is not this much cluster. I mean this much.
Hmm.
Okay, but the densities, when the densities are different, no. Okay, in that case, your distribution based algorithm won't perform well. Okay, it won't be able
Okay.
to, I mean, cluster it into two different groups because it counts the number of points also, no. Okay, I mean,
Hmm.
yeah, and if you go to the logic, no, I mean, it will won't be able to cluster it like this. Okay, how it will do is that it will make it as a one cluster, and it will make, I mean, other points as a second cluster based on the distances.
Okay.
Yeah, or maybe I should make it like this. Let's say you have so many points here. Okay, and there are points like this one. Okay, like this.
So if something is very close and far apart, two different
Uh-huh.
clusters are possible, then
So in this case, no,
distribution will not work
yeah,
well.
yeah.
We have to
In
choose
this case, no,
density.
if you use distribution based clustering like k-means clustering, no, because it
Hmm.
in k-means clustering I mean you focus more on the distance part. So what will happen? No, it will
Hmm.
make cluster like this as cluster one and this as cluster two, right?
Okay.
But ideally the cluster should
That's
be
that
something like this.
implementation.
Yeah, yeah. So ideally the cluster should be something like that. So that is there. Let's move to the next question. You are building a MLP class. Okay. Yeah, okay. You are building an MLP classifier for a data set with a large number of features. The goal is to predict whether an online user will purchase a product based on their browsing history. You are trying to decide the appropriate number of minerals in the hidden layers. Which statement about the hidden layers parameters is correct? So here, no, I mean, hidden layer size is the hyperparameter which you need to adjust based on the thing like whether your model is underfitting or overfitting, or I mean at least yeah, whether the based on the performance of your model. Okay, so I mean if you increase the number of hidden layers, then it is a chances that I mean it will not always lead to the better model performance, because and after a certain time now it will try to overfit. Okay, if you decrease the number of hidden layers, the number of neurons in hidden layers, then yeah, it reduces the model's capacity to capture maximum complex pattern. But yeah, after a certain point, no, I mean you will try to underfit it. Okay, so that is there. The number of neurons in hidden layer does not significantly affect the model. It affects your model performance. So finding the optimal number of neurons is a trial and error process and may require experimentation. So that is true. Okay, so that's why this is a hyperparameter. Okay, you have to get
Okay,
the
sir.
optimum value. Okay, you are designing a MLP classifier for image recognition task. You want to introduce non-linearity. Non-linearity you can introduce using the this one activation function, right? So that is there. Okay,
Sir,
and
if I am not wrong,
mm,
the neurons, that second option B, it is perceptron only, right? And perceptron is a linear function. And once we pass it an activation function, then only it gives the non-linearity, right?
right, right. So the question says that you want to introduce non-linearity in the neural network
Uh-huh,
architecture.
okay, I understand,
Yeah.
but that's what my main logic for canceling B.
Uh-huh. Okay. Yeah. So, okay. So question number 33. You are working with a data set of customer purchase behavior, including attributes, total amount spent, number of items purchased. You decide to use k-means clustering to segment customers into groups based on these features. Okay. Okay. So here the question is based on the given code and nature of the data set, what does the variable labels represent? Label simply represents the number of, it simply identifies the cluster name. I mean, it simply gives some label to the cluster. Okay, the cluster which they have
Clustering.
created. Let's see the option. The total amount spent by each customer. The cluster assignment indicating which group each cluster belong to. Yeah, the
Uh,
cluster assignment indicating which group each cluster belong to. So B is
So
correct.
D option is for cluster underscore center.
The cluster centroid coordinate. Right, right. Cluster center. The centroid coordinates of the cluster form. Right.
mm,
Yeah. You are working on a binary classification task using the MLP classifier to predict whether a customer will make a purchase based on their browsing behavior. You are concerned about overfitting due to model complexity. You want to increase the alpha parameter to control overfitting. The following could, uh, by setting the alpha band, how are you affecting the model, affecting the neural network model's behavior? I mean, yeah, you are using this alpha is simply your regression
Regularization.
parameter. Anything related to this will be there. Yeah, I think option B says that. Okay.
How is it then discouraging complex models?
Again,
Because
here
increasing
also, right, right.
regularization means reducing overfitting and thus increasing the complex boundaries.
Sorry, what do you said?
It discourages now.
See,
You are
if you
not
are,
fitting
if,
complex
Increasing
yeah,
the
count.
regularization, sir, increasing the regularization means reducing overfitting, right?
Yes.
increasing the regulation means,
Overfitting only complex models. So more complex the model, more it will overfit, right?
Okay.
see, yeah,
So
if you are
we are
taking the your,
regularizing, we are increasing the, so we are making it more simple, right? So if we have something which is like a very simple model, like only like the very basic model, it will be like more general, but it will also not fit properly. So then we'll have to reduce the regularization. But then if we reduce it too much, we'll get something that fits it exactly, tries to match everything.
No, if we
just
are adding regularization, then it is overfitting, right?
no. See, if you are, see, here is, this is your bias variance. Okay, and I mean, in this side, no, you are increasing complexity. Okay, so see, what you have to understand is the, when you increase the complexity, I mean, when you make I mean, too much sophisticated model, in that case, in that case, what will happen is that your I mean, you will try to you are simply trying to overfit. Okay, or maybe you can use the, I mean, increasing complexity simply means that you are trying to overfit. Okay, I mean, you are making, I mean, very sophisticated model. Okay, and due to that, no, your model performance on training data will be high but very poor on the test data. Okay, in this case, no, in this direction you will increase the variance and you will increase the complexity. So let's say if you are at this point, no, your variance is high and your model is very complex. So if you want to move from this point to this side, no, you have to use regularization. Regularization will reduce the variance and also reduce the complexity. Reduce, or I mean, in other word, I mean, if you are regularizer simply means it will make your model simple. Okay, it will try to regularize your model's parameter by making it simple. Okay, simple means reducing the complexity. Okay,
It's like how the complexity and the overfitting is related. The complexity of a model and overfitting.
okay, yeah,
No, but
increasing variance
More
means increasing the complexity.
variance.
Okay, decreasing the
uh,
variance means decreasing the complexity.
I just want to know like how the complexity, like a model being a complex, like a simpler model
Huh.
considering a logistic regression, a simpler model, a
No, no.
complex model is an MLP classifier model, is a complex
Okay, okay.
model.
So
So
okay,
like how
yeah, okay.
complexity is like that's what I was saying. Is how the
Adding more
complexity.
neurons to hidden layers, adding more layers to hidden means that MLP, both are considered as complex because in general neural networks, as you go like beyond 3 or 4, in general, if you don't have a good data set or small data set, then it will cause an issue, and then it will start to fit the data very well, but it will perform very bad. So that's overfitting. And as you increase more and more number of neurons and layers, then it will fit more complex boundaries, uh, like that, so that the bottle means like the data gets fit very good. So that's the overfitting thing that is happening here, and that's how your model is becoming complex. So if you try to reduce that, you have to introduce regularization, or you have to use the dropout method where you are randomly cutting out some of the neurons output.
No, that's fine, but I'm just asking like increasing the complexity, how it increases overfitting. Like overfitting
Okay,
means your
see,
model is not
huh.
performing good on the validation, but it is performing good on the test
Yeah, complexity simply means, see,
training.
let's say, okay, let's, I mean, let's take a simple model, I mean, linear regression. I mean, there you will be easily able to I mean, understand it. So there are these points. Okay, these are the training points. Let's say, I mean, or I mean, yeah, these are the points. Okay, and you want to create a line, okay, which is able to predict all these points correctly. Okay, so in that case, what will you do? Okay, there is a two option here. One option is that you just directly simply try to fit a line like this. Okay, this line will give some error for this point, this for this point it will be able to predict, I mean, very accurately. But for this point also, like it will give some error. Okay, I mean, the error will be minimum. Okay, this is something like that. But let's say if I'm asked you to give me, I mean, better model than this one. So, I mean, there will be one person like who will come up with the line like this, right? So the equation of this line, okay, the if some person comes with the equation of line like this, no, he will be able to predict all the points correctly with zero error, right? For this training data. But
Yeah.
next point, let's say somewhere here, for this point, what will be the output? I mean, it will just it will just try to follow this line equation, no? Yeah.
Mhm.
So overall for new data, yeah.
So like, what do we conclude from this? A simpler model is better than a complex model for
No, no,
a.
no. Always simpler model is not the I mean, not a good thing. And yeah, complex, I mean, always the balance. Okay. You have to optimize things. Here also in this case, no, you have to optimize this single line. It is possible that, I mean, in this one, maybe sine curve is the better option in this case. Okay, not this exact this line. I mean, not this exact this line, but yeah, sine curve, that can be the better option here. Okay, based on this point, we can say, or maybe you can increase the data point so that you can understand. You can, I mean, you can understand more about the pattern, right? So see, you have to conclude that neither, I mean, completely very simple model is not also a good thing, and very complex model is also not a good thing. Okay, so you have to come up with I mean, something in between. Okay, let's say you have these points. Okay, only 4 points are there as of now, or maybe yeah, only 5 points are there. So out of these 5 points, no, there can be one model like this. Okay, I mean, this straight line, maybe all the points are lying in this. Okay, this option one. Okay, second option can be like this one. Okay, which is nothing but the exactly sine curve. Okay, like this. Okay, and third option can be like this. Maybe some other color. Okay, it will directly go from here. Yeah, it is not looking good. I mean, and then you like this. Okay, so this is the third option. Okay, I mean, just see that, no, this is not a sine equation. I mean, this one is I mean, straight line equation. This one is a sine curve, and this one is this yellow line is something, I mean, even more complicated than this your sine curve. Okay, so like this, out of these, no, how you will decide which one is the best one? It complete, or I mean, okay, it completely depends on, no, let's say on it completely depends on your new points. Okay, if let's say if new points follows, I mean, if new points are here, here, and here somewhere, no, and yeah, I mean, if new points follows this one, this pattern, no, then you will say that yeah, your linear equations were better. Okay, or if that point also follows, I mean, are very close to your sine curve, no, then sine curve was better. But yeah, if that point, no, or if that points are not, I mean, following this exact this pattern, okay, I mean, this yellow color pattern, then it simply means that yellow color was overfitting. Got it? Or I should say in some other words.
It's clear now,
Yeah.
sir. So it's like
So that,
we should try with each and every model, which one is good. Uh,
right. You have to, I mean, yeah, you have to try out. Okay, I mean, but just by, so that's why you use regularization, no? See, even in linear regression, what happens? So, I mean, if your model is not giving you good accuracy, you use polynomial transformation. Polynomial transformation is simply that instead of fitting a linear a straight line, you are trying to fit a, non-linear line. Okay, I mean, instead of fitting a single line, you are trying to fit something like this. If degree two is this one, degree three can be like this. Okay, I mean, once you increase the degree, you know, no, I mean, how your lines changes. So that's why, I mean, even after improving, so in linear regression, what will happen? If you want to overfit or you want to improve your model complexity, you know, you just simply increase the degree. Okay, you saw, no, at degree one you had just one x and y. Degree two you have one x y x. I mean, you have earlier you had only three features. Now you have you have five features. Okay, when you will increase degree two from two to three, then you will have more number of features. Okay, simply you are making your model more complex so that you can predict it better. Okay, so that is there. Okay, ultimately at the end, what will happen? No, I mean, even after beyond a point, you will simply end up memorizing the data point. Okay, exact data point. So that will happen. Okay.
yes, got it.
Yeah. Okay, so I think yeah, that's all. Let's not talk about the topics like which you should focus on the different weeks. Okay, I think here we have the syllabus, right? Not in this one.
So syllabus is on the course page.
Okay, okay, about the course. Okay, sorry. Here, this one.
No, no,
No, no,
sir.
no, this
It
one.
is like
Huh?
where you have the course details and everything in general, not for
Okay,
for
do
IITM.
you okay, okay? Do you have that? Okay, okay. Do you
Wait
have
a
that
second.
link? That link? Uh, courses.itm, right?
Yes, sir. I think that's the one.
Team. Okay, okay. Okay. This will open the ITM courses, not the courses.study.itm. I think something like that. Okay. Otherwise, I'll just go manually. I mean, whatever I'm able to remember from the weeks. No. Let me see the topics. So yeah. Yeah, in pandas, just revise the manipulation techniques. Like yeah, you have different things. No, I mean you use value counts, queries are there. Yeah, filtering options, slicing things. Just revise those things. Okay, and how things works and yeah, how you have to use them. Okay, so that you can revise. Okay, and then in week 2 you have things like yeah, different preprocessing techniques are there. I mean one hot encoding, min max scalar, standard scalar. Okay,
Sir,
revise
I
those things.
shared the link.
Uh, have you
I
shared?
shared the link that you have.
Okay, or otherwise also, I mean, this is making more sense. I'm able to remember the topics from here.
Sir, from the week wise you can tell, means
Ah,
from
yeah, yeah, from here also I'm able to remember, collect the things. Okay, yeah. So like this, no, you can revise things. Okay, then in the column transformers, I mean, then yeah, how column transformers, how feature unions are there. Okay, that those things were in week 3, I think. Yeah, and different data extraction techniques and imputation techniques. Okay, then yeah, a column transformer pipelines are there. Then feature union, these things were there. Okay, and then you have yeah, this we talked. Yeah, revise the PCA things, feature selection. There were methods like variance threshold and all were there. Just revise those things. Okay, yeah, I think this much. Okay, from week 3, week 4. Let me see. Yeah, linear and how linear regression works. I mean, just you should be able to work on the I mean simple data points. Okay, I mean how it works. Okay. Uh, then nothing. Yeah, SGT regression. Nothing. I mean, just revise the. Okay, for all. I mean, this is for all questions. I mean, just open the sklearn website. Just go through the I mean details. Okay, I mean for each APIs. Okay, so that is definitely required. Okay, then yeah, you have polynomial regression. So you have already I mean we also discussed today, no, I mean how polynomial regression works. So that is there. Apart from this, I think yeah, regulation parameter. Okay, I mean what happens when you increase the regulation parameter, what happens when you decrease the regulation parameter, L1 difference between L1 regulation and L2 regulation. Okay, so the codes related to grid search, randomized search. Okay, how things works in these two cases. Okay, and then apart from this, I think yeah, there were matrices. No, I mean different confusion matrix, RAC, AC score, mean max score. I mean no, not mean max score. I mean precision recall. Okay, so those things you should revise. Okay, and then yeah,
F1 score.
F1 score. Yeah, that is also there. Okay, and then yeah, multi-level classification, classification. These things are there. Okay. These things are important. At least, yeah, this much at least you should definitely revise.
All type of models also, na, sir? Like
Yeah, models. Yeah, you should practice all the models. I mean, or at least in the models, like where I mean, it is possible to discuss or it is possible to get a solution easily. No, those models we may ask you. I mean, we may give you some simple data points, and yeah, based on that, you have to decide it. Okay, and then yeah,
even
suppose like
parameters also,
huh.
implementation in terms
Yeah,
of
yeah, so that yeah
implementation.
that yeah that is yeah in terms of implementation. So this is what I'm saying, that in terms of implementation how it implements. No, I mean just if the model is very basic, no, at least yeah this is possible, no, then you should just practice that part. Okay,
Okay.
then apart from this, I think yeah, I mean definitely I mean the parameters of these models. Okay, I mean the as I told you, no, I mean this is very important. At least okay, I mean open each and every API on sklearn website. just go through their parameters and different attributes. Okay, and yeah, I mean
Okay.
methods available to those. Okay, so that is required. And then I think yeah, in week 8, I think yeah, I think PCA we already talked. And apart from this, I would say yeah, the models like decision tree and all, that is there. I think week 9 you have. Okay, week 9, yeah, decision tree. Okay, how decision tree works? I mean there are different parameters, important parameters here in this one. Yeah, bagging, boosting. Okay, I mean how things works. I mean there are different many models. I mean in bagging and boosting we have talked. Just go through their parameters. Okay, I mean that would be important.
Okay.
Okay.
Sir,
Yeah.
activity question also has those, right? So can we do activity question for?
See, the best thing is that okay, I mean whatever suits you, do that. Okay, and the first priority should be to go through. I mean, if I talk about the learning part now, first should be. I mean,
Hmm.
you should go through the skill learn part. Okay, I mean the just revise the attributes and all. Then yeah, if you
Okay,
have
sir.
practiced the previous papers, no, I mean that is enough. But yeah, if you want to go beyond that, then maybe you can try things. Okay. I mean, yeah. Otherwise, I will just tell you. I mean, just you should be able to thorough. I mean, how those model works. Okay. Let's say, I mean, if I mean for each model, no, just try to think. Okay, if I give you some simple uh, input, no, then will you be able to solve it? I mean, without running the code. Okay. Or yeah, what would be the logic? So that is there. And then yeah, different. I think yeah, then yeah, here you have things like ensemble models. You have the like ADA boost bagging classifier, gradient boosting classifier. Okay, and the parameters which we have seen already. Then yeah, I think yeah, these things are for the prepare. I mean for end-term preparation. Yeah, in yeah, I think in week 11 we have talked no k-means clustering. Okay, and HAC is there. Okay, hierarchical clustering. So those things just revise, and
Mm-hmm.
MLP
Have
classifier. Yeah, MLP
PG
regressor is there.
scan.
Yeah, just to revise the parameters of hyperparameters of these models.
Okay.
Yeah, I think that will be enough for the I mean in term papers preparation.
Sir,
Yeah,
what
thanks.
is important in bagging and boosting?
Just revise the I mean see directly what I cannot say anything. I mean directly what I would say, to prepare tagging and boosting, the common questions just search on the Google. I mean there will be some like how variance happens, how I mean variance, I mean what happens, I mean if you are working on, I mean what is the difference in bagging and boosting. I mean one of these to try to come control the variance, and one of these to try to control the way back I mean bias, just to revise those things. Okay, so that is there. And apart from this, no, in yeah, just revise the parameters. So I mean different hyperparameters. Okay, what happens like when you increase the max depth? So what happens when you increase the different minimum leaf node or something like that? Okay, so yeah, Purnendu, I think you want to ask anything.
Sir, just one question. It's like we have used a lot of data sets in this particular course. So
Uh,
will there be any questions where we have to the data set will be imported, and based on that particular data set,
no,
question might
we
come like
won't. We
available
the
data set.
question. I mean, we might be running the data set, but definitely, I mean, see those things. I mean, what you do not need to remember anything from the data set. Okay, just
Okay.
keep.
Okay. Hmm.
Yeah, if required, no, I mean, we will give that value. For example, let's say, I mean, in these questions, no, for California also, we mentioned, no, that these many number of columns are there. So, I mean,
Hmm.
you don't need to remember that.
Okay,
So,
sir.
yeah, things will be like that. Uh, yeah, I think that's all from my side. I think, yeah, this would be the last session for, I mean, this term for MLP course. So maybe, yeah.
The December term
Thank you,
question
sir.
paper has a lot of
Thank you, sir.
errors.
Sir.
Okay,
December
thanks.
term question paper has a lot of errors.
So that is possible. So what happens now? I mean, after the term, no,